All right, welcome to MVP Days, everyone. Our online edition. Everybody knows what's going on in the world here, and us as a community, especially the Azure Stack HCI, Azure everything community, are so pleased for everyone to be able to join us. I'm so lucky to be joined by my fellow co-presenter, Mr. John O'Neill Sr. My name is Dave Kawula. And we are here to talk to you today about something very special, which is Windows Defender Advanced Threat Protection, specifically for our core critical infrastructure. So with that, John, I'll hand it over to yourself for a quick introduction, and we'll go ahead and get started.
Thanks, Dave. And I am also so excited to be here. Working from home these days during self-isolation. So I'm excited to get out and participate with the community in an event like this. So that's about all I have to say to intro. I'm excited to get in and have our conversation and our presentation.
Now, I got a question for you, John. When you're looking at technologies like this, it's important to step outside of Contoso land and do this in production. So I'm actually really pleased to let everyone know that we've been working together on a large-scale production rollout of Defender Advanced Threat Protection, Office ATP, and all of the Microsoft Security Suite together for about the last 6-7 months. And so this is a little bit of our notes from the field as well as just a session, right?
Absolutely. And, you know, that's what I really enjoy is moving out of the ideal environment of Contoso and seeing if it holds up to all the hype out in the field. And I think you and I both agree it absolutely does. And that's what we're here to share today.
So I think during this session, you've actually prepared a few samples for us of some sample alerts that we've seen coming through, as well as some of the operational emails and things like that that we send out when we actually have an incident that we need to respond to, right?
Yeah, absolutely. I mean, a big part of a strong security response team, if you will, is communication, right? A big part of any team is communication. So we have to standardize that. We have to make sure that it's something that is easily recognizable and understood by employees and all those things. And we're going to get into that today.
Awesome. Well, let's take a look at our agenda that we have. Let me see if I can advance my slides here, see if technology will work for me here today. So what we got in this jam-packed session, we're going to try to get this done in about 30 minutes or so, is we're going to go through a quick overview of Windows Defender Advanced Threat Protection, and maybe not exactly in this particular order, because I think I may have mixed up some of the slides. That might have been my fault. We're going to talk a little bit about the Security Center, so the Microsoft's dashboard and portal that we've got for Defender Advanced Threat Protection. And then more importantly, some long-term protection techniques by using what we call a fabric. And we'll discuss that in a minute. We won't let the rabbit out of the bag just yet here. And we're going to talk about why that portion is important, combining not only rigid security practices as well as seeing what we can do to fix existing environments. So that's what we've got for everyone today, John. So let's go ahead and get started here. So the number one thing that I think that you should take away from the session is your existing environment that you have is more than likely compromised. Would you agree with that statement? That's a pretty bold statement that I'm making there, John. But if you've been running an Active Directory domain in an Active Directory forest for any extended period of time, that environment's connected to the internet and it's been running, there's a strong likelihood that you've had some type of a compromise at some point in time, or there's an attacker that's waiting in the weeds waiting to come and get you. And this produces a very interesting quandary that we have as what I'll call fabric administrators, because we're supposed to build hardened and secured infrastructure, but if your home is messy and you go to bring new stuff into it, everything's just going to continue to be cluttered and messy. So our theory is, why not start in a brand new, fresh world where we can reduce the amount of domain administrators. Just a virtual show of hands of you out there. How many of you listening to this video today have a problem with privilege access inside of your environments? You know, we all like to say that we control the domain administrators that we have out there, but a lot of us are in situations where those decisions were maybe made long before we ever started working inside of these environments, and we have too many administrators inside of the infrastructure. Okay. The second one is that maybe you don't have multi-factor authentication enabled, and you should do this on all your systems inside of the Fabric. Well, we had a situation, John, which was twofold for one of my customers. I actually just did a webinar for Veeam. I think it was just earlier this week, actually. And basically what we talked about was the fact that, you know, we had this Azure Stack HCI infrastructure installed into the primary domain for this one particular customer, and the attacker was able to get domain administrative access through a pass the hash attack technique, and they ended up gaining access to all of our Azure Stack HCI infrastructure, all of our backup infrastructure, everything that we had inside of there. And so what they ended up doing is, you know, this attack wasn't even so much of a ransom as more of a destruction exercise. They were going around destroying clusters, destroying backup targets, you know, breaking things. So how do you prevent that from happening? Well, having an alternative set of credentials and a separate Active Directory force and domain is a great starting point. And the interesting point is that, you know, if you're in an environment like this where everything's installed in a single domain right now, and you don't think you have the ability to do this, well, starting in Server 2016, John, Microsoft introduced a technique where we could move Windows clusters to a brand new forest, and I use this technique all the time for my customers. And so I've got a link to one of our blog posts that's the case of migrating an Azure Stack HCI cluster to a new Fabric domain. We've detailed step by step that entire process of moving existing clusters, so kind of remediating and fixing a problem at hand. And this is just such an important starting point for security, because your security is only as good as your weakest link. And if you continue to operate in an environment that has a whole bunch of holes in it, you're going to have problems. So
absolutely. And if you don't mind me jumping in here,
yeah, no problem.
I want to, you know, really reaffirm to everyone that I totally agree with the assessment that the longer your AD, your identity management solution, has been in place and running, the more likely it is that you are already compromised. And how much you're compromised is directly related to how long that system has been running. So if you've been running Active Directory since, say, Windows 2000 days, when it first showed up on the scene, you probably have way more compromises than you think, or maybe even are willing to admit. And by getting a Fabric, by getting a separate management identity management system, so I know I used management twice there, but what I'm really talking about is you have this separate identity management solution that's governing the accounts that can control your Azure HCI stack clusters. So control your hosts and your nodes and that sort of thing. And the other thing about that, as Dave alluded to, is that you could have this huge, diverse user community where turning on MFA is a political nightmare, right? So it's not a technological nightmare. It's one of getting, first off, management to buy in, and then developing a plan for how it's not going to disrupt operations and all that kind of thing. Well, that could be a long-term thing, and I'm a firm believer in MFA everywhere, but that could take a lot longer. Whereas if you have this separate identity management solution with minimal management users in there, turning on MFA is typically not difficult. It's something that, you know, Dave, you and I have done in minutes, right? The whole process of turning it on and enabling it and creating conditional access policies in Azure and that sort of thing, and then testing it out took us less than an hour for all the admins. So it's a huge deal, and we can't recommend that enough. And Dave, now I'll jump back out.
Well, and along those lines as well, just the number of administrators that are required inside of the Fabric. Well, the Fabric is really, you know, your most sacred environment. It's where the Holy Grail is kept. You know, if you're going to get into the Fabric, you're going to be able to get into the underlying domains that live underneath. So you really don't need a lot of administrators inside of there. I like to actually talk to my customers about almost having only break glass accounts almost inside of the Fabric, because you shouldn't need to go into there very often, except for, just core management capabilities, like, restoring some of your infrastructure and making sure that everything's running. So it's not a daily driver type domain like what you'd have for your normal infrastructure. So a Fabric is definitely a must. Now,
and if they don't agree with hey, we can't keep it just break glass, my feeling is, well, fine, then let's start there. And as you prove you need something else, then we can add that in. Because the fact of the matter is, we've all seen this. Once someone has domain admin rights, they are loath to give it up. They will fight you tooth and nail to give it up. So if you don't assign it in the first place, you don't have that fight.
Well, and John, I often get asked the other question as well, is that, okay, fine, you've built the Fabric, but building the Fabric is just a start. So when we talk about a Fabric, let's just clarify what that terminology is, what that actually means. It means you standing up a fresh Active Directory forest and domain, having a couple domain controllers, separate DNS, all of that stuff runs your Fabric resources. And that's where all of your Hyper-V hosts, your clusters, your backup targets, all of that stuff would live. And so locking this down and protecting this is a very important part. But you're going to ask me the question. Well, I have no idea where to start. I'm not a pro at Server 2019 yet. I don't know where to start. What are all the recommended security settings? How am I going to pass this upcoming security audit that we're having coming through? Well, introducing the Microsoft Security and Compliance Toolkit. This has all of the pre-built group policies that you need to lock down that environment, from your domain controllers to your member servers. And the good news is that I have tested this against Azure Stack HCI, specifically the third one from the bottom, which is the Windows 10 and 1809 and Windows Server 2019 Server Security Baseline. I've tested that and it works, okay, with very minimal configuration editing inside of there. It's not going to blow up your Azure Stack HCI clusters, okay? So from my testing, I put this out on multiple different customers, and everything's been running fine for us. So the important part about that is that, listen, we've got a way to actually further lock this down, which is great. But then it comes the operationalization part of this, is that how do I ensure that I stay protected? How do I ensure that my servers are up to date, my Azure Stack HCI infrastructure is up to date, and all my VMs that are running underneath are up to date? Well, as you may or may not be aware, Microsoft included antivirus starting with Windows Server 2016, and it was called Windows Defender Antivirus. It was an offshoot from their endpoint protection solution, their forefront endpoint protection solution that started to come out with System Center Configuration Manager, and it was just eventually baked right into the operating system. Now, the cool part about this is that it is actually baked right into the OS. You don't have a third-party download for it. But if you don't have what we call Windows Defender Advanced Threat Protection, which is an add-on, I feel that it's almost like you're using a freemium version of the product, right? You're not getting the enterprise feature set. So what you need to do is the rough cost right now, and please don't quote me on licensing. I hate even putting a number inside of there. But the rough cost is around $15 per server per month. And what it does is it builds this into what I would call an enterprise security suite from the freemium version that you would be working with. And so it is a definite must. If you're running Windows servers, you need Defender Advanced Threat Protection. The onboarding process for Server 2019 is incredibly simple. You can get your older servers in there as well, but there's a little bit of additional work that goes on with that, and we'll talk a little bit about the onboarding process, but this is a definite must for you. All right. So when we talk about moving into this Fabric, John, and operationalizing and securing Azure Stack HCI, this configuration is not enough, right? we need to do something called operationalizing the team. And maybe you can speak to this for a moment, because this is one of the intangible parts of every IT project that I find that a lot of our IT pros struggle with. This is moving away from the speeds and feeds of the technology into the people and the personality of what's going to take and is what's going to roll out long term. This is what I call the beyond the 30-day deployment plan. This is from day 30 to the end of year 5, right? So the end of your 60 months technology life cycle. That's the operationalization part. This is when your consultant walks away and your team is left with the support of said tools. And what are some of the important parts of operationalizing technology specific to Defender ATP that we've learned, John?
So it's kind of ironic that we're talking about this here in this conversation, because anyone who's attended one of my talks over the last couple of years, whether it be at TechMentor or Live 360 or MVPDays events, has often heard me kind of pose a question to the audience of who here considers themselves IT security professionals. And usually just a handful of people will raise their hands, but a bulk don't, right? They think, oh, I'm a developer, or I'm a help desk admin, or I'm a network admin, but I'm not really a security professional. And my answer is wrong. Everybody who currently works in IT is an IT security professional. The fact of the matter is security is so pervasive and so important now that there is no aspect of IT where a knowledge of IT security isn't necessary. I don't care if you're in development, or if you're in the help desk, or if you're in a management role, you need to have some operational understanding of what IT security means. Otherwise, your organization is at a higher risk than competitive organizations, and that is a bad thing to have. So operationalizing is a critical component of any fully vetted security plan for an organization. And by operationalizing, I mean, Dave, you and I have done this a lot. It involves a lot of conversations, a lot of training, a lot of lab time for the team so that they can see what this looks like. And then a phased approach of getting them into the administration cycle of the live production environments. You don't just drop them in and go, here's your credentials and hope it works out, right? See, hope is not a strategy. So we can't do that when it comes to security. We have to take a methodical approach of getting them up to speed and then letting them prove that knowledge through lab examination and then live fire exercises, if you want to think of it that way.
Well, and these templates that we're going to show here as well, these are just some of the ones that we've built, because this really didn't exist prior to us going through this project, not that I've seen out there anyways. I've got a question for you. Are these templates, these samples that you're going to be taking and showing here, John? Are you going to make these available on your GitHub repo as samples for the community?
Absolutely. I'm excited to do that, because as I mentioned when we were kind of in our intros, communication is key. And these templates that you and I have create a 3-tiered process for communicating with users, management, the security team, the HR team about what's happening in the environment, right? And what's important is you take these templates in advance after you've created them, get buy-in from your executive management teams, your HR teams, because what this does is it sets a baseline and a very specific procedure for what's followed for cascading security events. Hey, when a user's PC or a user's account triggers an alert, the first time, this is what we tell them, this is the information we share, this is how we respond. The second time, this is the information we tell them, this is how we respond, this is who we add into the communication process so that they can be involved. And the third time, same kind of thing, lather, rinse, repeat. And to give an example, in the last environment you and I set up, the first incident, that of course goes to the user. It also goes to the local IT team and the corporate IT team. And then it also goes to the local HR manager and the local office manager. Now, if that same PC or that same user triggers a second event, the information goes to that same group, but now we add in the corporate HR team. And on the third time of a subsequent incident, then it goes to the executive management team along with the executive HR team to make a decision on what is the appropriate action, right? And in that organization, they have, laid out in their employee manual what the punishment for improper use of IT technology is for users. But this way, IT doesn't get in that position of, hey, you're treating me wrong, or hey, why did you treat me more severely than Janie or Johnny over there? Because you're treating everybody the exact same. Even the words you're using are exactly the same.
Well, and then I think there's one big piece that goes along with this as well, John, and I'm hoping that we'll be able to share some samples of, just general IT policy and procedure, because this goes into the acceptable use agreements and stuff that our teammates are going to have before they can do anything on the network. And so that's also a big portion of this, and we make sure that we send those out as a copy with every one of the incidents that we have, because it's not just about setting up the malware protection solution. It's about the intangibles that are in behind, about what do you do when you get an incident. And I'll use that word very clearly, not if, when you get the incident, because you will get an incident. We found very quickly that once this was deployed, that we saw incidents coming through. And this is what the ATP alerts would look like. So this is a sample of an ATP alert that had come through, generated from the Microsoft ATP infrastructure. And basically this one here was actually pretty current, wasn't it, John? This one here was May 10th. That was just yesterday that this one came through. And it was some auto run malware was detected. Now this alert happened to be on one of our Windows 10 machines. But the nice part about this is the setup and configuration that you'll have for Defender Advanced Threat Protection for your Azure Stack HCI infrastructure is actually exactly the same as your Windows 10 infrastructure, correct?
Yes, and I want to throw out there that May 10th was a Sunday, so Defender ATP and the communication isn't just limited to work hours on work days. It's 24/7, 365.
And then this is where we get into the guts of what I consider this is a real gold nugget, John, is the template email that you've crafted around the compliance policies. And this is what we were talking about, is that, listen, we need to have a notification chain in here now because something has happened. There's been a security incident. So this security incident, why don't you walk us through a little bit of your thought process as you were crafting this?
My pleasure. So first off, this is for an initial incident. So I want to take the approach, I want to have the tone that this is just an honest mistake, right? This isn't somebody actually trying to work their way around the system or do anything nefarious inside the employee's day-to-day. It's just the employee made an accident. They clicked a link they shouldn't have. They went to a site maybe they shouldn't have. Whatever, but we're going to take the approach that it was just an honest to goodness mistake. So it's important that we give that tone, that we don't come off as threatening or as a big bad ogre that's kind of coming to stomp them. So you'll notice that we use some terminology that helps us set that tone, like unfortunately, and even at the bottom we talk about, hey, these are the best practices, and we're going to get a hold of you and we're going to answer any questions you might have. So we're setting that friendly, we want to help you tone that hopefully allows the person to not get their defenses up and shut down, but instead they focus and they they really try and learn. So as we begin in the email, you're going to notice there's 3 spots there that I've pulled out with arrows where I immediately share information from the Defender ATP portal. And this is going to include information as a type of malware that was detected, right? The progression chain of that malware. So, hey, it arrived on my PC, and then my PC tried to infect these 6 other PCs, and maybe those other PCs were across a VPN network to another organization. We're going to show that here in the screenshots. And we're also going to show any of the particular files that it tried to run, like the auto run and that last alert. If the account was running as a local admin, Defender ATP will show us that as part of the incident, as part of the alert. And there is a specific paragraph in here that covers that, right? Hey, in violation of IT policy, your account was running as a local administrator. Notice the tone of this is a little more stern because Dave, you and I both agree on this. When something is running as a local admin, that is a much, much bigger deal that requires a stronger, faster response, I guess is the best way to put it. So,
well, and I think that's a good piece to point out as well, is that the Defender ATP alerting mechanisms, through root cause analysis capabilities of the tool, actually allow us to tell exactly what user was logged in, what type of credentials said user had while they were logged in. Even if it was a service account that was executing something, we can go right back to the moment and second as to what was happening, and then also collect investigation packages, because, you know, if this was a malicious attempt, you're going to be talking about some type of legal actions that you're going to be having to take surrounding this, and you have to collect all of the evidence.
yeah, and if you know, you're to the stage where you're implementing the entire Microsoft Threat Protection Suite, where not only do you have Windows Defender ATP, but you also have Office 365 ATP and the Azure ATP side, right? This is going to tie into quarantining email chains, right? Because maybe you need to lock that down for possible litigation later on, or understanding the identity management concerns. A great use for Azure ATP, for one thing, is to see where somebody is maybe using a domain admin account to run services across your HCI clusters. That's a big one. That we've found a few of those, haven't we, Dave?
Oh, what was the record that we had, John, for a domain administrator account running applications?
It was in the hundreds.
Hundreds and hundreds of services that were running under the context of a domain administrator account.
And because remember, that particular domain admin, every time he set up a piece of software or configured a SQL server or whatever, he's just using his domain admin account.
Yeah, exactly. All right.
So to finish this off real quick, we cover, and again, we set that nice friendly tone of, hey, we're sure it's unintentional. Here's some key points. So before a member of the IT department contacts them, before they have to open up any of the policy documents that we've also attached, they're going to get some key pointers, like don't click on links from unfamiliar sources. Don't try and open any attachment that has particular extensions, right? Don't share your username or password with anyone. Basic stuff that unfortunately a lot of users, because their job hasn't really pushed them to know basic IT security, their job is something completely different. They may not have this at the front of their frontal cortex of their brain or whatnot. So we're going to put it right there in front of them. And that's the basics of this alert. And like I said, it not only goes to the teammate and the IT teams, but also to local HR, local management, so that they're aware that this has happened. Now you can move on to the next.
Awesome. Absolutely awesome. Okay, so the Defender ATP experience, it comes in the form of a portal, securitycenter.microsoft.com. In fact, today, if you're watching this video, I highly recommend it. Go securitycenter.microsoft.com. You can see if you are set up for this. If not, there'll be a little bit of an onboarding experience. You can start a trial for the service inside of there. And you just basically have to set up a Security Center trial with Azure, and you're good to go. Very, very easy onboarding process. docs.microsoft.com also has a very good set of robust instructions on how to set this up. In fact, we've also authored a book on this, John, Defender Advanced Threat Protection for Server 2019. We document that process as well. And that's not the goal of this session to get into it, but this is where the portal comes in. The portal gives you a very rich and robust experience for managing the security landscape via Defender Advanced Threat Protection. Now, in order to have your Azure Stack HCI infrastructure talk to Defender Advanced Threat Protection, we need to onboard these machines. Now, we have the ability to take and to onboard them manually via script. We can onboard them via group policy, or we can onboard them via common configuration tools like Config Manager or Microsoft Intune if you're set up to manage your servers with that. For your workstations, obviously, if you're pushing this out as mass, you're probably using some type of a configuration tool. John and I have used all three methods. They all work extremely well. All right, so let's talk a little bit about, before we go into a sample incident here, John, about the Microsoft Digital Security and Risk Engineering team and what I'll call your partner in security, because it's nearly impossible for us as IT professionals to stay on top of every single security incident, alert, trend, tactic that are out there. We need a partner in this. And Microsoft, if you're running Microsoft operating systems, if Microsoft is already your trusted platform, you're already using Microsoft Azure Stack HCI, it just makes sense to use the Microsoft security solution in behind this. Microsoft has an integrated solution where it's not just the Windows servers. It's also integrated through Azure. You get the AI components with that. It's also integrated through Office. You get complete visibility into what's happening inside of your network. And probably one of the coolest parts about this is watching the proliferation of malware as it attacks something inside of your infrastructure to see exactly which machines, which accounts, what lines of code it's actually trying to execute across the network. In fact, we caught one that was wrapping some PowerShell, right, John? And inside of the PowerShell code, we could actually see exactly what the malware was attempting to do.
Yeah, that was really cool to be able to see it to that detail. And I will throw in here that part of that, like you see along a lot of these tiers, you have security incident and event management seem listed. And to just show how much Microsoft is investing in making sure that all this ecosystem is in place for you, Azure Sentinel is really coming onto the scene, which is cloud native SIEM that you can use to integrate and all this. So that's another big part of it. And it really shows how Microsoft, if you have a Windows-based environment, they're really going all in on creating a security team for you and security resources for you.
So, John, I have a question for you. The day of an attack happens. Unfortunately, it's today. And we feel that we don't have the level of knowledge or understanding in order to take and to work our way through this. One of the key pieces of advice that I have to give to our listeners right now is that Microsoft actually has threat experts that are available as part of their security operations center. You can engage them through the portal, through the securityscenter.microsoft.com portal. Let's say that we had one of those alerts like we saw on the previous slide pop up, and it's bad, it's spreading, and we don't really know how to stop it, and we need help. The threat experts portion of this is something where we can engage Microsoft, and it alerts them to say, listen, we've got something critical going on inside of our tenant. Let's escalate. Let's get some help. So that's available for us. In the event that you do have something like a ransomware attack that's proliferating through your environment, most organizations, and I'm going to call out one vendor here, Veeam Software, because I just had to work with them in February for another customer case. They actually have a dedicated cybersecurity and ransomware team that's available for you. So just be aware of that. Most of your vendors that are out there are going to have some type of cybersecurity response team that will be available to help you with whatever products it is that you purchase. So don't just feel like you're left on your own because, like I said, security is very big. It's very broad, and sometimes you just need help. Don't be scared to call in your vendors because they probably already have teams that are available waiting to help customers with these situations when they come up. All right. How does Defender help us? Just a quick slide on this. Deployment and management. It gives us a portal, enterprise-like configurations. It scales. It's got cloud scale with Microsoft. Precision and speed is something I'd really like to touch on here, John, because we have had a chance to extensively play around with the isolation capabilities that are available. So, for example, let's say that we have a incident inside of our Hyper-V farm, and a Hyper-V host or node or something like that is compromised. Is it possible for us to restrict access to that? And how fast does it occur when we hit the isolate button?
It's absolutely instantaneous if the machine is still connected to the internet and can receive the command. But even if it takes some time, that's because the machine isn't connected, and it will be instantaneous when they connect back. And so think about that for a minute. The machine's off. Well, if it's off, it's not harming anything. But as soon as it turns on and connects to any network with internet connectivity, so even if the user has taken it to their house and boots it up, it will instantly receive the isolation command and lock down, right? And it can either be locked down in entirety, or we can leave Outlook and Teams communication so that we have a way of communicating with the teammate. But I know, Dave, you're in my own preference is to isolate the machine completely until we know what we've got going on, and just call the user on the phone or reach out to them so that we can have a more interactive discussion than email provides anyways.
And there's a back channel where the Defender ATP portal can communicate with that resource that it's managing, but it prevents it from spreading and causing further harm. From an Azure Stack HCI perspective, I would caution the use of that button because you're going to instantly take a node offline and stop all network connectivity. So you will break RDMA, you will break anything that's going on, storage spaces direct and Azure Stack HCI related. So you just better be darn sure. If it's a VM that's running inside of Azure Stack HCI, feel free. You can knock that off the network, no problem. But if it's actually one of your nodes that's causing issues, the Defender ATP portal doesn't understand how to differentiate between an Azure Stack HCI node and just a PC that's out there or a server that's out there. They see them all as just Windows devices that they're managing. And so just be very careful with the options to lock those things down. So that's why I wanted to bring that up. Okay, so John, we're at about the time where we're going to have to wrap up soon. So why don't we show what a sample incident would look like? I think this was originally demoed at Microsoft Ignite was one of the first places I saw this particular example. And so John and I have a lot of use cases like this ourselves. We've seen many forms of alerts come through. But let's take an example of somebody trying to hijack RegServe 32. So we see that alert pop up like what you would have seen in the previous slide. We come into the portal. Inside of the portal, what we would do is we would click on the alerts. And so the alerts would show what's sitting inside of the queue, and we would click on that, and it says something has happened here with the Microsoft command line utility RegServe 32. It looks like something malicious has happened inside of here. There might be some malware, and it's come in through through user init, and something's happening, right? So you can take a look at just kind of exploring your view through the queue. As we come through the queue, we can see that there's an incident graph. And so there's one really important part inside of here. And John, I'm just going to see, I was going to draw in here. Let me just see if I can grab my pen here real quick.
Well, while you're doing that, let me throw out that these are the screenshots that you're going to take and include in those template emails, the screenshots that you're going to see through these next few slides.
Yeah, exactly. And so this one here, what you're missing is it's kind of grayed out here. That's a computer name. That's the source of infection. This is a remote computer. These are all remote computers. These are all remote machines that this thing has attached to. And so it looks a lot different when these are not grayed out, but this would be a SAM computer account name, SAM computer account name. All of these would be computer accounts, and we can see that the same command run, and it would tell us the time of execution, everything inside of here. But that's an important piece of this as we take and we go through. We just go back to normal, and next. I got to get rid of my drawing here, John. Hold on. Erase all drawings. There we go. Okay. So now this thing's attached, and inside of here, we can also see inside of here, there's a bunch of things that are grayed out, like the usernames and things like that for the actual machines that are being attached. And so another thing I wanted to point out, just see where it says the logged on users in the last 30 days. This will show you all of the user accounts. And what's one of the things that we look for inside of here, John, especially on our workstations that are out there, because you should not be doing this, is logging in and seeing domain admin access accounts that have been logged into this workstation. Highly privileged accounts logging into workstations. I can also use the same thing for servers, because why are my accounts logging in all over the servers? We should use the principles of just enough administration and remote access on these things. We should not be seeing a bunch of local accounts logging in. Now, we're trained right-click jockeys, so we like to log in and Control-Alt-Delete, but this is very important. We can see all of the users. Under the Actions pane here, you can start going through and doing your collecting investigation packages. We can see the builds. This is an example against a Windows 10 machine. You can see other really important information like the IP address, because now I can tell if this attack occurred while this user was over a VPN, especially in today's realm of COVID and things like that. We want to know if this is a remote or if this is something on our LAN that's taking place. And so this is really important. And then we can see the actual user accounts that are executing. We can see what's going on, and we can see the alerts going through here. Okay. So that's just one really important part I wanted to point out, because we're graying that out. Now, John, I'll let you point out this one, because this one's kind of neat, because in the example here, we're drilling into this is called our timeline view, where we can actually see what's going on at what time. And we can see that something nasty happened with RegServe 32 at around 8:20:29. And we can see that RegServe 32 tried to run a command line. That looks a little weird, doesn't it?
Yeah, and it tried to connect to an external resource, right? That's a big one. Grab a DLL from the internet.
And so we've actually seen this, and this is really important from an investigation package perspective, especially if you're managing the firewalls, because now maybe you can actually block access at the firewall level to these particular resources as well, right? And all of this plays true for your servers as well. This is not just Windows 10. This runs exactly the same way on Server 2019. We've seen it straight across the board. Okay, and then we can.
Yeah, and it's a great point you make about being able to use this information to integrate other security remediations, right? This is why we call it a security team, because it's not about a single solution or a single person. It's about communication and collaboration to achieve the end goal. And to do that, you need to involve those network administrators, those firewall administrators, those server administrators, and those workstation administrators.
Here's us just checking the URLs, so we can go through the portal and check the URLs as they're being hit. And that's about what we've got for this particular session. So with that, everything's compressed at MVPDays Online. On behalf of John and myself, guys, thank you very much for attending our session. Tons of additional resources up on our blog. John is actually a resident blogger up on our blog, checkyourlogs.net. To date, almost 1 million views up there and over 600 posts of IT Pro related information. And our last resource that we have for you is all of our books that we have. The big thing, I don't know why I put a Bitcoin icon up there. That's funny. So our MVP Days Scholarship Fund, this is something that we're really proud of. It's something that we can do to give back to the community. All of our proceeds from our books, and I've just given a sample link up there. You can just search LeanPub if you want. Just go ahead and search my name up there. You'll see all of our books. We've got close to 20 up there right now. All the proceeds of that go to our MVP Day Scholarship Fund. To date, we've given out 2 scholarships. The scholarships are valued at $10,000 each. And we're so pleased that we've been able to take the proceeds from those books and have a way of giving back. It's our way of helping out our future generations of IT. I really hope you enjoy the rest of MVP Days here. Once again, on behalf of John, myself, and the MVP Days crew, and all Microsoft MVPs and everyone in the community, stay safe out there. And thank you very much for attending and watching MVP Days online.
Thanks, everyone. Stay healthy.
Hello everyone and welcome to this 30 tips in 30 minutes. My name is Jan Tore Pedersen, JT for short. I'm a senior consultant at CT Global here in Norway, and I was recently awarded the Cloud and Data Center MVP. I mainly focus on storage spaces Direct and Hyper-V, Azure Stack HCI mainly, System Center products, software-defined data center, Azure, and Azure Stack. And of course, any other Microsoft on-prem solution. I have a blog at jtpeterson.com. I also tweet with the handle Jan Tore P. Recently, I also got involved with the System Center user group here in Norway, and I'm hosting events focusing on System Center data products. So this is going to be 30 tips in 30 minutes. So each tip is going to be pretty fast. So let's have a look at tip 1. So the first tip we have is visit the official Microsoft Docs page for Storage Space Direct. If you're looking into Storage Space Direct, I recommend you to go to this web page and read everything. And what I mean everything, understand how Storage Space Direct works. It is not like setting up Hyper-V. It is a lot more complicated, so you need to know what you're doing. Tip 2. A lot of you probably heard the motto, well, it can be run on everything. And it can. But if you're going to be running it in production, you need to find a certified configuration from your favorite vendor at the official Azure Stack HCI page, which you can find here. There is at the moment a lot of different deployments you can do from vendors like Dell, HP, Lenovo, Dataon, Fujitsu, and a lot of other vendors as well. So you'll probably find something that'll fit your brief. There's everything from hybrid scenarios to all-flash to 2-node scenarios. Tip number 3. Again, going back to you need to know what you're doing to deploy storage spaces direct. So read through the tier 1 vendors deployments guides. If you're buying another vendor's hardware, make sure they have a deployment guide, and also read through these 3 guides. They are very thorough, they are very good, and they cover everything you need to know about deploying storage spaces direct. Tip number 4, Windows Admin Center. Most of you have probably heard about Windows Admin Center and should know this. But if you haven't and you haven't tested it out, please do so. It's a great tool to manage your hyperconverged infrastructure. It takes less than 5 minutes to install and gives you a good web-browsed GUI of managing your storage spaces direct clusters. And you can download it at docs.microsoft.com. Tip number 5 is view your storage spaces direct cluster with Windows Admin Center. Here you have a very good view, overview of what's going on with your cluster. You can see there's no alerts. You have 4 servers, how many drives you have, how many virtual machines you have, if your volumes are okay, your CPU usage, memory usage, storage usage, and IOPS. And you can even drill down into volumes or drives to see what's going on. Tip number 6, disk latency outliers. This is a new feature that came in Windows Server 2019, and it's a really nice way of figuring out if one of your disks are failing. So when you go into the drives of your in Windows Admin Center, you can see at the bottom there is something called Show Latency and Error Statistics. If you click on this button, it will retrieve the statistics. It takes a while. It takes a few minutes for it to get this, and then it will show you the amount of how many milliseconds your IOs are doing. So for instance, you can look at thresholds here. So I have a lot of IOs that are over 1 millisecond. The next one is 4 milliseconds, so 12.47% of all my IO is over 1 millisecond. But if I go drill down to the next stop, it will be a lot more in the percentage. And if you can see at the top on the right corner, it says average latency is 356 U, which is pretty good for a cached device. And it'll show you how much read bytes, total IO, write bytes, and so on. Tip number 7. Now with drive latency outliers, there is some scripts you can run as well to get this out in a different format. And you can even script it so that you can get a report with PowerShell. So Cosmos shared these scripts with us a while back. So you should look at this page and see if there's something here that you can use. So how do you manage storage spaces direct? Well, with Windows Admin Center, you can manage a single cluster or a single Hyper-V server. But if you want to manage more than one cluster, you should use Virtual Machine Manager. It has a bunch of things you can use to manage, like you can do networking, you can do logical switches, logical networks, deployments, and stuff like that. I did a session about that in February on the Storage Spaces Direct Day. So on the MVPDays YouTube channel, you should be able to download or view the recording of that. So deploying and managing your hyperconverged S2D solution with Virtual Machine Manager. Tip number 9, designing a storage space direct cluster. So this is with every other Hyper-V environment. You should not go over 4 vCPUs to one physical CPU, but leave yourself a little bit of room to grow. So if you have like three something virtual on an average of virtual CPUs to a physical, that's fine. If you are at 5, maybe you should choose a bigger CPU. And another thing is with Intel, you have to fill 12 and 12 slots of memory. So it's either 12 or 24, depending on how much memory you have. And if you need to, maybe let's say in half a year, 2 years, need to add more memory, just fill the first 12 slots and then the 24 slots. But filling 24 will give you a better performance on memory. Cache drives. So for hybrid setups, the recommended is minimum 10% from Microsoft. I tend to spec from 15 to 20%. We've done a one that was 25%. This gives you more cache to capacity and allows you to have more of the active data in the cache, meaning your cluster will be a lot faster. For all flash, you can go as low as 5% of your capacity. Now, if you, for instance, buy an all flash server that has 24 slots, you fill it up with 4 cache drives and only 10 SSDs, you should probably be 10% cache to capacity with the 10 drives in case you want to add the other 10 drives so you don't go below 5%. And always use NVMe over SSD as cache. This is two things. One is that NVMe is getting very close to pricing of an SSD. In my area, it's about 10% difference in price from NVMe to SSD. But the other thing is you get so much lower latency on NVMe, and it's directly on the PCI Express bus, and you don't have to share the SAS bus with the HDDs. That can fill up your SAS bus. Networking. So, should you do Rocky or iWarp? It depends. I'm a Rocky guy because I know how to configure it, as Rocky uses UDP, so it needs DCB and priority flow control to control if there's any congestion. With UDP, there's no acknowledgement that the package is received. So it's a little bit more complex to set up, but for any initial deployment. iWarp uses TCP, so it has the acknowledgement of if any package is being dropped. So it will retransmit. And it does not require DCB or priority flow control to work. But we do recommend DCB and priority flow control for iWarp. Let's say you have a 100 gigabit network and you have saturation on that. It gets overflowed, or let's just say 10 gigabit for that sake. If it starts overflowing your network, there will be a lot of retransmits, and nothing will tell your network card to slow down. So we do recommend priority flow control as well on iWarp in case you fill up the bandwidth of your network cards. The more packages you drop, the slower your network will be. CSV cache. In 2016, it's off by default. It is on by default in 2019. It's a simple command if you're running 2016 to enable it. In 2019, the default size is 10 gigabytes. In 2016, if you enable it, it's 1 gigabyte. And it only works as a read cache, meaning it will only cache the latest reads. So it will speed that up. There's no write cache. That's what we have the other cache for, the NVMe for. Another networking tip is jumbo frames. Do I need it? Yes, you do. So if RDMA fails, it'll fail over to TCP/IP, meaning your CPU will offload the traffic. With jumbo frames, you put more data into one packet, so it will not congest your CPU that much. And it's nice if you do live migration without RDMA, for instance, between two clusters that doesn't share the same SMB RDMA network. Then yes, it will offload the CPU a lot as well. If you're worrying about performance issues and you're thinking, is my cache, what is going on with my cache drives? Daryl and fellow MVP created a script to be able to check your cluster's cache binding. So it will also check to see if there's any drives that are not bound to a cache drive. It will also see if your drives are unbalanced. Let's say if you have 7 drives and 2 cache drives, that means you have 3 drives on one cache drive and 4 capacity drives to one cache drive. You should have an even number. So if you have 2 cache drives, your capacity drive should be 2, 4, 6, 8, 10s. Same with if you have 4 drives, so you should have either 4, 8, or 12 capacity drives. If you have 3, it's like 6, 9, 12, even. And another thing is size your cluster shared volumes correct. I recommend a maximum size of 5 terabytes. Why? If your volume gets detached, there's an error on your volume and it won't come online again. You have to run scheduled task that is called data integrity scan for crash recovery. This scheduled task takes about 1 hour per terabyte used to scan. So if your CSV is 24 terabyte, which somebody I know had last year, and you filled it up with 20 terabytes, it will take 20 hours to scan through that volume and before you can use it again. So size your CSVs correct to the recommended size, to a size that fits you. Do not make them too big. If you have a virtual machine that has a volume of 10 terabytes, see if you can split that volume up and spread it over more than one CSV. I have a script on what to do, so go to the link in the presentation. Tip number 15, 3 nice scripts to know and to use on your storage space direct cluster. The first one is show pretty pool. This is very, very nice to see the balance of your cluster, to see how your volumes are, to see how the data is spread across your capacity drives. The other one is align virtual machines with your storage. So with storage space direct and any CSV cluster, aligning the virtual machines with where your storage is mounted gives you a better performance. So if we've tested this with the VM fleet, and if your virtual machines and the CSV are on different nodes, your performance can drop by 50%. So if you are high, you need high data, or let's say high response and good low latency, align your virtual machines with your storage. So meaning put your virtual machine on where your storage, on the owner of the CSV where your storage is located. Another thing from Romancere is a audit S2D script. It can audit your S2D cluster and make sure that everything is lined up correctly, or that all your nodes have the same configuration. Tip number 16, patching your network drivers and firmware. Always reapply settings like priority flow control, RSS, and others, and rerun your networking scripts after you patch network drivers on your service. We've seen that for some reason certain updates have broken settings like the priority flow control, some RDMA stuff stopped working, and then you have to reapply the settings. So always rerun your scripts and make sure that RDMA works. There is a nice PowerShell script called test RDMA that will check and see if RDMA is working. It will tell you if you have RDMA drops or whatever is happening. So always run that after patching as well. Now another question is patching, can it be automated? Yes, you can. You have two options. You have cluster-aware updating and virtual machine manager. Now cluster-aware updating is a very nice feature that's been there for a while and it works very well. You have the option of adding pre and post scripting, so you can run stuff to stop things and so on before you patch, and it's self-aware, so it stops if there's any issues or any errors. Virtual Machine Manager is a fully automated with Virtual Machine Manager. You can use baseline patches, baselines to patch to the firmware, to the patches you want, and you decide which patches that you want to put in. And it's fully automated, and it stops if there's anything issues going on. What it does not have is pre and post scripts that you can put in. Now, with patching, there has been issues where servers where your volumes has gone offline when you're patching due to some data being missed or something on one node or something. So Ben Thomas, another MVP, created some scripts and some routines on how to add something called storage maintenance mode, which is a way of setting your storage in maintenance and not and flushing your cache drives. So look at Ben's scripts in his blog post, and if you're using standard procedure or cluster-aware updates, implement his type of patching. Tip number 19. Are you behind on your patching of your clusters? Are you 6 months or more behind? Well, then we recommend offline patching. Why? Because we've seen issues where if you patch and your service hasn't been booted for a while and you try to install updates that are 6 months newer than your previous update, people have had issues. So we do recommend, if you're 6 months or more behind, shut down your cluster. So stop your virtual machines, run stop cluster, disable the cluster service on all the nodes, and then do your patching, and then revert when you're starting up again. Tip number 20, moving a storage space to direct cluster. So in some scenarios, people are moving their storage space to direct cluster from one data center to another. You can do this basically the same way as you do a offline patching. So you shut down all your virtual machines, run the stop cluster, disable the cluster service on all nodes. Then you shut down all the servers. And the very important thing is make sure you know where everything goes, meaning cables, switches, that everything is correct as it was before. So that when you boot up, it gets all the networking stuff and all that stuff up and running. And make sure there's a domain controller running before you start your Hyper-V nodes. So move it and then do all the steps in reverse. Once it's up, check that your virtual disks are okay with get virtual disk and that no storage jobs are running with get storage jobs. Once that's done, you can restart your virtual machines. So one of the other things is on tip 21 is how do you see if a disk is about to fail? So I showed you drive latency outliers, which is a really nice tool to see if there's any issues with a drive. And then the PowerShell script that you can automate to send a report that if a drive is failing or is about to fail. The other thing is you can use performance monitoring. I've used this a lot when I'm troubleshooting a storage space direct cluster that somebody has reported is being slow. So what you want to do then is you want to open up Performance Monitor, go to physical disks, and then have a look at the average disk sec read, average disk sec transfer, and average disk sec write. The numbers here should be as low as possible. NVMEs and SSDs should be in the 0.00 something range. So the lower it is, the better. Is it above 0.010, then it might be something wrong with that physical disk. So if a drive fails, replacing it can sometimes be an issue. Replacing a failed drive is easy enough. You just retire it, remove it from the cluster, add the new one, it will automatically pick it up. But replacing a cache drive should be the same. If it doesn't work automatically, have a look at my blog post here. It's a combination. I should probably write a new one, as these are from 2016 and 2017, but they still work. Now, dedupe. If you want to run dedupe, you need to tune it. You need to tune the schedule outside of backup windows. And also if you do Hyper-V replica, tune it so that it doesn't be so storage intensive while it's doing all its different things. Dave Kavula, our host, has a very nice blog post about how to performance tune your dedupe schedule. So I recommend you to look at that. Tip 24, and this is a big dedupe tip. Do not use dedupe and storage replica on a high performance system where there's a lot of load. Dave has had issues with it and others as well. And I've tried it, and if you load the cluster a little bit too much, it makes things a little bit slow. Tip number 25, once you're done setting up your cluster, you want to performance test it. So what we use is VM Fleet, which is what most people do. It's used to benchmark your Hyper-V storage. It can be used for a SON as well, because it only requires a cluster and a cluster shared volume. You can download it from the link under on GitHub, and then if you want to know how to set it up, there is quite a few blog posts out there for it. I've used about 3 different ones to get mine the way I want it, so have a look. Another tip is Jeremy's WSLabs. So you should go and look at that. It's very, very, very nice. He just also posted a really nice new scenario with Grafana, which has some really nice monitoring features. It shows some really nice GUI of your performance and how the storage is in Storage Spaces Direct. It even includes CPU and memory monitoring as well. Another monitoring tool is System Center Operations Manager, which is what we recommend our clients to install, as it has a lot of things. And it's the only monitoring tool that works great with events, services, SDN. It has some predefined management packs as well that allows it to, out of the box, just monitor what you need and gives you alerts of it. But there can be some noise, so you need to use so I recommend using a third-party web GUI to sort out all the different noises that are there. Tip 28, backup. This one is very, very important. Make sure your backup vendor supports STD and CSV or RAFS. I have seen some of the bigger vendors, not Veeam, of course, and some of those, but that does not support Storage Spaces Direct and CSV or RAFS. To name one, Backup Exec do not support it. So, and it will have cause major issues with your CSVs. Tip 29, here are some nice blogs to follow to get information about this S2D Azure Stack HCI updates or any issues we're having, or anything we want to share that we've learned or done during our time. So it's Dave's blog at checkyourlogs.net, Ben Thomas's blog at bcthomas.com, Daryl Vanderpale as well, Didier Van Hoy at blog workinghardinit.work. Then you have Carsten Rockfall's blog at hypervserver.de. This one is in German, so for any German speaking people, this is the one to follow. And then, of course, my own blog, where I try to tell you as much as possible of my day-to-day S2D experiences and what's going on. And last but not least, if you have any questions, have any issues, or just want to chat and talk with a lot of cool people, you can join our Azure Stack HCI Slack channel at azurestackhci.slack.com. And thank you very much for joining in on this session. I'm still JT Peterson. Thank you very much.
So hi, we're going to talk about Windows Server 2019 and persistent memory, because persistent memory rocks and I just love it. My name is DJ Van Hoyer, better known as Working Hard in IT, and anything you want to know about me is on this slide. So have a look at it, play it back, but we are going to continue with persistent memory. So what is this? Well, it's quite easy. It is storage at the speed of memory. And what's not to like about the speed of memory, right? So there are a couple of persistent memory types. There are the non-volatile DIMMs, the NVDIMMs. There are different variations of them. You have what some vendors call storage class memory, SCM, and then there is memory class storage. But don't get caught up in these semantics because things are changing and NVDIMMs are different to storage class memory, but that is more or less true depending on the type, etc. Memory class storage, however, is a category of its own. So the two examples that we have here are the ones you can actually buy today easily. That's NVDIMM-N and 3DX Point from Intel, their Optane series, right? The persistent data center memory. Now they can both be used as normal memory or as persistent memory, and you can access the storage either in direct mode, so at the byte level, or block addresses, which means like ordinary storage as you know it today. So DAX is a lot faster than block access, but block access of course has the advantage that it works with any application that exists, so it's backward compatible, so to speak. To use DAX you need applications that are DAX aware. Now these variants in NVDIMM are N, F, and P. N is basically just memory DRAM mapped to the memory. Flash is not mapped, and it's only used for persistence. The flash is there with a battery pack, and we'll discuss this a bit later. Other things to know is it's very fast, it is very low latency, but the capacities are literally tied to the capacity of memory DIMMs, so that's 8 to 32 gigabits. Maybe later they will grow a bit, but there is a limit there. The NVDIMM-Fs are very special ones. They are actually flash put on a memory stick, so you can put them in a memory slot, but that also means that they are very slow compared to memory, they have high latency, and their capacity, of course, that's the big one here, is a lot bigger. But it's a niche market. It's available, but it's vendor specific, and have never seen it in the wild. And then what we are aiming for in the future is NVDIMM-P, because that will combine both flash and RAM to be memory mapped, so you can have direct access or byte access. It has the latency of NVMEs or better, and they have larger capacities. This is not available, however. We should get it in the DDR5 timeframe, but still it's not available. So how does that NVDIMM-N that we have now today available to us work? Well, actually everything is happening in RAM. And the moment you shut down the server, or you have a server crash due to a blue screen or because you lose power, you have this battery pack that's needed to put all the data that's in memory into that NAND flash. And if you boot, then it all has to be reloaded into the system. And that's what you see happening with a server when it boots. It's actually arming the NVDIMM-N and it's restoring the memory. So that needs to happen. The F, we've discussed this. It's slow. You can use it now today with DDR4, but it's a niche market. That NVDIMM-P, which combines the best of both worlds, actually looks a lot like what storage class memory does, right? You don't really need that battery pack anymore. You have some capacitors on the module. You have both DRAM and NAND on there, and it isn't available yet for NVDIMM-P, but that storage class memory, however, is available, and that's what we call SCM from Intel Optane, the DC persistent memory. So you have the higher capacities, which is what we want. You can use it with DDR4, so it's usable today. However, what you need to remember is NVDIMM-N, for example, can only be used with specific BIOSes, so it has some dependencies on the server, but these can only be used with certain types of CPUs from Intel and not from AMD and not with other CPUs. So they all have their dependencies and their requirements. It's not just buy them and just drop it into any old server you might have lying around. And then, of course, the memory class storage that we have today, or that we are looking at today, we have Nano RAM, we've got RRAM, we've got Magneto RAM, and it's all very cool. It's all the best of both worlds. It has all the benefits of memory without the drawbacks of memory. It has all the benefits of flash storage without the drawbacks of flash storage. So this is pretty cool, right? This is very low cost to make, could go to high capacities. It should be a lot faster than Flash or NVMe, so it's memory-like, has enormously high endurances, at least the promise of it, very high reliability in terms of long data retention, but also in terms of being able to operate under extreme temperatures. It has very low power usage, and that also means that because it's like storage, you don't have that refresh cycles of memory, so it's a lot more efficient. What's not to love? There's only one thing wrong with this picture. It can do everything in the world apparently, but it doesn't get out of the lab. So we're waiting for this one. Now, why do we care? Well, we have this ever bigger need for faster and bigger storage. And we have been doing quite well in speed. You have on the top end and let's say the expensive end, we have the L1 to L3 caches that you find on CPUs. It's very fast, but it's also very expensive and very small. And then you have the run-of-the-mill server and PC memory that you know. On the bottom end, we've gone from HDDs to SSDs to NVMEs, and along with that, we changed our connectivity type from IDE to SATA to SAS to PCIe buses, and now with PMEM, we are trying to do that with memory slots. Why? Because, well, we have this need to bring our data to the CPU for processing as fast as possible. So we've been achieving that, but going to the memory slot is the fastest path to the CPU. And why do we want this? Well, the data has been growing exponentially, and if you look at the curve, it's quite kind of disconcerting how fast it is going. How the predictions are actually almost unbelievable. But this is happening, and then all this data needs to be used, parsed, processed in relational databases, in memory databases, in scale-out storage systems, and then we're gonna run big data analytics against it. And they all need to get to that data as fast as possible, hence the need for PMEM. Now, it's all about value. I mean, you are not going to buy this to increase the speed of a Microsoft Access database. Let's be very clear about that. It is not for everyone, but when you need it, and then it makes a huge difference. So let's go to the next slide here because I'm stuck. So if you look at the entire spectrum of hardware, we are getting ever faster memory. The network speeds have gone up to 200 gigabits per second and are still rising. We have gone from SSDs to NVMEs, and now we have the PMEM, all that in very modern hardware. So things on the hardware side are looking actually very good, and it's the software that needs to catch up now. So we were going to talk about Windows Server 2019 because we are at a certain state with Windows Server in regards to how it can use persistent memory. So let's look at that. In the lab I had NVDIM ends, so that's what I'm talking about. But what I'm telling you is, let's say, usable for any type you can get, which there's two of them, right? NVDIM and the Intel obtains. So we have to turn it on the BIOS for NVDIM ends, and this is important. If you forget, well, then it's ordinary memory. As I said, you can use them for both use cases. And then there's another one you would like to see and pay attention to is NVDIM interleave. You can disable it or enable it, and for now we'll leave it disabled. So what does that mean if you have a system like that and you've booted? This is what you'll see in Device Manager. And if you run get pmem physical device, you will see 6 devices, which because I have 6 in the server. 3 per CPU socket. Then you can run get pmem unused region and you will see 6 regions. 1 region per device. And that's because we have not used interleaving. So you still don't see a disk here. What you need to do is grab those regions and turn them into disks. And that's what we're doing right here. And once you've run this command, you will see the persistent memory disk show up over here. It takes a little bit of time, but not too much. And if you then run get pmem disk, you will find the disks. That's as simple as it gets, actually. Now, we've talked about that interleave thingy. Well, let's do that. Let's go into that BIOS and enable it, and then boot our server. You will still see 6 devices. You will still see 6 devices in PowerShell, but when you do get pmem unused region, you will see you have only 2 regions. We have actually aggregated these devices per CPU socket within the same region. So we have 2 regions, 3 devices in each region. If we now grab the regions and create pmem disks from them, you will see them appear here as interleaved persistent memory disks. Why do you want to do that? Well, basically because you want to create disks of higher capacity. The thing to notice is this is a very neat trick. It's very, let's say, recommended that you use this depending on your use case. But it has one thing you need to consider. There is no redundancy. So if you lose one of these devices in an interleaved disk, the disk is gone. So that's if you want redundancy and protection against that, you will have to go higher up the stack. It will have to be the storage solution that provides it for you, but it isn't built into the physical disk. So how do we consume that? Well, we've created the disk, so we find them when we run get pmem disk. You can also say get disk, basically the commands you know from all types of disks in Windows, but say, hey, I want the bus type to be SCM, storage class memory, and then you will find them. It's you can see the numbers, so you will take those raw disks, you will initialize them with GPT, and then you'll create a new partition, assign a drive letter, format it, give it a file label, and then you can choose to use isDex, true or false, and if you use DAX, then you can do that direct access to the storage, which is very fast. But not all applications can use that, but for SQL Server, for example, for log files, this is great. And if you want to check if a volume is DAX, well, fsutil is your friend. Now, once you have that disk, as I said, SQL Server could use it in DAX mode, or even your file server could use it in block mode and be the fastest file server on earth, if you have the money and the need to do so. Probably not, but you can. But there is another way. You can consume this pmem directly in the virtual machine. So how do you do that? Well, you need to have Windows Server 2019 Hyper-V, and then there's some requirements. That means you can only use Generation 2 virtual machines, which isn't too big a deal. You want to use them anyway. Then you have this new disk type. The VHD pmem extension defines actually that the virtual disk is a persistent memory disk. And those files have to be created on an NTFS DAX volume. That means that Hyper-V is DAX aware, just like SQL Server. For now, you can only create fixed size persistent memory disks, but that's not a biggie. And the command is the most familiar command you probably know in Hyper-V if you are creating disks in PowerShell. The only difference is the disk extension, which defines it as a persistent memory virtual disk. Cool. Now, once we've done that, we've got the virtual disk. Now we want to use it in a virtual machine. But to use it in a virtual machine, we need to add a virtual machine pmem controller to it, which is a very simple command. Then you add your hard drive to that virtual machine to the controller that you just created, and that's it. You cannot mount this virtual pmem disk to a standard SCSI controller. It needs to be this pmem controller you added. Hence the controller location. Normally the controller location 0 is the one that's default. So inside that virtual machine, it just shows up as a disk. So if you run get disk in that virtual machine and you specify the bus type as SCM, hey, there is your persistent disk. And Hyper-V knows this is a persistent disk. It sees this. And then again, you create a drive, a volume, you partition it, you format it as NTFS, and you could choose to even use it as a DAX volume or not, because inside of your virtual machine you can run SQL Server, which is DAX aware. Or if you want to use another workload that needs block level access because it doesn't know about that direct access, well, use NTFS without a DAX option and you're good to go. It's as easy as that. Now, all good and well. Got a new disk type, you have some new capabilities, but what does that do for you? Well, this is a virtual machine, and we are running a 4K workload with 24 workers, 100% read and 100% sequential. So that's a pretty easy optimized workload for getting high IOPS. And look at what we're getting here. 1.5 million in a single virtual machine with 2 persistent memory disks. That is nice. I was really amazed to see this, because normally you would need 12 to 16 node clusters with all kinds of tweaking and very expensive storage and networking to make this work. And now I've done this on a single Hyper-V host with a single VM, just like that. Now, it becomes even better, because I thought, now let's do something more realistic. Let's go for the 8K workloads with 24 workers and 70% read, 30% write, and make 30% of the I/O random. Well, look here. It's still 1.44 or 1.45 million IOPS per second with a very decent latency. Okay, you have to give the machine a couple of CPUs, of course, to handle all that workload, but this is very nice, and I was really so happy to see this, and I got kind of addicted to it. It's always hard to give that sort of hardware back to the people that actually bought it. Now, I was also playing with disk SPD to see if I could get the same results, and well, basically this is the same test with the 30% writes and the random I/O, and I got to 1.75 million IOPS at a latency you would kill for, basically. So this is pretty neat to see. The only trick that you need to remember is you have to disable, that's what this is, the SH option. You have to disable caching, because otherwise, if you try to do caching, the hardware is so fast that the caching in the software just can't keep up. So you're actually reducing your performance. So with disk SPD, don't forget to disable the caching. But this is so neat. You could do this all week long, month after month, and still never get bored of doing so, because it's so great. Now, as we said, only Generation 2 VMs are supported. You also need to make sure that you create a VHD PMEM disk on your NTFS DAX volume, and you can do some neat things. You can still convert VHDs from VHD PMEM to VHDX and vice versa. You can select your atomicity at creation time, that is either none or BTT, and BTT is block translation table. Normally, in an SSD or an NVMe, you have protection against torn sectors because they have capacitors or some firmware that handles that for you, but you don't have that with PMEM. So if you do block level access, you need that protection or you run risk of data corruption, and that's what selecting block translation table does for you. Also funny is, just like a regular virtual disk, you can mount it in the host and read and write data from it, which is kind of cool. And for now, you can only create one virtual PMEM device from that translates into one VHD PMEM file. You can't create multiple on the same device, but that is for the moment the case. I don't know if that will remain, but that's something I noticed. Both DAX and BTT is supported in the guest, which means you can run SQL Server and optimize it for direct access, or use your block level workloads. You use large pages automatically for better performance, but you have some negatives as well. There's no live migration to this point. I'm pretty sure they will build it because the competition has it. There's no way that you can do a checkpoint on those disks, and backup is also missing. And then again, save and restore is not there, but this is less important to me, and maybe to you as well. But it's good to know that these are the limitations at the moment. Now, there is another way to use PMEM, and that is in S2D, Storage Spaces Direct. Now, you can use it as a storage tier. So then in that case, for S2D, the recommended file system and the one you always use is REFS, but that doesn't have DAX support, which means if you were planning to run native SQL Server workloads on that cluster, that's not going to happen because then you don't have DAX. Well, you can still run SQL Server, but not have the direct I/O in that case. And of course, the recommendation is to make sure that you use interleaving, so you aggregate the disks to have higher capacity. Because otherwise, I think the biggest one at the moment, if you use the Intel Optane, is 512 gigabytes. So you might want to, add a couple of those in an aggregate via interleaving to make them bigger. But you can also use the PMMS cache, and then you don't have to worry about REFS and DAC support because it's just a cache, right? You don't need to worry about the overhead of block level access. Caching has nothing to do with all that. Still, you might want to use bigger disks for your cache, and then interleaving again is the recommended way to do so. Now, the good thing is, I told you with interleaving that there is no redundancy. If you lose one of the physical devices, you lose the entire interleaved persistent disk. But S2D, of course, is the storage layer that provides the protection against disk failure, and that takes care of that for you in this case. With Hyper-V, you don't have that. If in Hyper-V one of the disks devices goes bad, well, you've lost your virtual disk. So that's something we'll have to see how they address that in the future. And if you put that in a nice picture, you will see if you use your persistent memory in a capacity device use case, then if you've got the money and the taste for it, you can build an S2D node completely out of persistent memory. Have a ball. Now, in reality, you probably might want to combine it as a persistent memory or storage class memory in combination with NVMEs or even with SSDs. There is no HDD in here because that is, let's say, lipstick on a pig. Days are way too fast to combine with HDDs. That would be nonsensical. You can also use disk caching devices, but again, same deal. It's going to be persistent memory with NVMEs or SSDs. It doesn't really make sense to use it with HDDs. Now, as I said, S2D, your disk is a normal fallible disk, and S2D will provide a protection against disk failures. That's the benefit you get here. But you might have noticed something. I said REFS is used with S2D. S2D doesn't support DACs, which means that on S2D, how do you create a Hyper-V virtual machine with a persistent memory file if you have to create it on an NTFS disk with DACs? Well, you don't. That's basically the answer. And then there are some interesting observations to make. If you look at a picture from Microsoft, you will see the physical device, and then there are 3 drivers types associated with such a device. The PMEM sys, which is actually taking care of the I/O and the management stages of the logical disk in Windows. The NVDIM sys takes care of the physical management, and then there's the SEM bus, which talks to ACPI sys to the BIOS, so that's for power management, for plug and play, all the things that have to do with the BIOS interacting with the physical PMEM device. So being an inquisitive boy, I went to look around for where I could find them, and yes, if you go and look in Device Manager and you go to the physical devices, you will indeed find the NVDIM sys driver associated with that physical device, just as it says in the picture. And yes, if you go to the logical disk, the persistent memory disk we created, you will find that PMEM sys driver associated with it. Cool, so where does that SEM bus sys live? Well, you go into your system devices, and then you find it over here on the storage class memory bus, and here is the driver. So that was a bit of snooping around to find them in the system, which is always cool. Just checking up if they are not telling us anything that isn't true, or if we can find what they are telling us, which is also nice. And then there's always this nice thing. Everything from Microsoft that is brand new seems to have been created with a driver in 2006, which is kind of funny. I always find that funny. Now, conclusion. This is absolutely fantastic technology. We are not where we want to be yet. And the big one, of course, we're waiting for is NVDIM P, because we have a hope that you can use that in more servers in the future and with multiple CPU vendors. Of course, Intel isn't staying quiet. They are working on next generations of that Intel Optane. And then, of course, there's that memory class storage, the Valhalla of storage, that will be all the benefits of memory without the drawbacks and all the benefits of flash without the drawbacks, all combined in one. They have the potential to be used in portable devices like smartphones. What if your laptops could be made with such disk? It's so fast it could boot in less than a second, and if when it's shut down or in a power save mode, it consumes virtually no battery or power, so your devices last longer. Anything that's portable and needs persistent storage that is highly fast, capable, low power consumption can benefit from this. And that means our storage systems and Hyper-V as well. So it's going to be very interesting to see in the future where this is going to. But again, all these new technologies like NanoRAM or RRAM or MagnetoRAM, they are very, very interesting. But unfortunately, despite the progress they've made over the years, they are still in the lab and they seem to be stuck there. So I don't think this is going to go super fast. I think we're going to see a couple of years before we see those appear at an affordable price rate and at a decent availability. But also, it's about time that NVDAP came onto the market, because that's been going on for a while as well. And things are not going as fast as we technologists would like it to be. But that's kind of normal if you live at the cutting edge. There's this saying, right? We are always 6 months away from the state we want to be in, or a year away from the state we want to be in. And when we get there, well, it just repeats itself. But I hope you found this interesting and you have learned something about persistent memory and why it is so great and where you can use it today. It is not perfect, but we are getting there, and I'm pretty sure that the next version of Windows is going to hold some surprises and some very nice additions to the capabilities with PMEM. So thank you for joining my talk, and I'll catch you all later. Bye bye.
Hello everyone, welcome to this Designing a Secure Azure Stack HCI Fabric with a Fabric domain and VMM. My name is Jan Tore Pedersen, JT for short. I'm a senior consultant at CT Global here in Norway. I'm also a cloud and data center MVP. I have my own blog at jtpeterson.com. You can also reach me on Twitter and our Slack channel. I'm also a co-organizer for the System Center user group here in Norway. My main focus area is on-prem with S2D, Hyper-V, System Center, software-defined data center, Azure Stack family, and Azure. And on my spare time, I build rotary engines and I work on my RX-7. So in this session, I will hopefully convince you to move your Hyper-V servers into a secure Fabric domain with Virtual Machine Manager as your management platform, along with Windows Admin Center. So why do you need a separate and isolated Fabric domain? Well, to put it simple, how long can you be down for without your company going bankrupt? Or can your company survive a total loss of data where everything is deleted or crypto locked, including your backups? It happens. Well, in most cases, the answer is maybe a week offline if you can restore. If you can't, well, most of the time it's the end of the road. Let's say you're a hoster and your environment gets hacked and crypto locked. Telling your clients that, well, our environment was deleted or crypto locked and our backups are gone as well. That is not something that is fun or something you want to do. Over the last few years, there's been plenty of evidences of attacks happening where the end scenario has been the end of the road for a few companies. There has been a few large hosting companies in the US that has gone belly up, and there are other companies that have had major issues where it has cost them a lot of money. like Travelex and Tesco Bank that was affected by the Sudinobiki, like Travelex and Tesco Bank that was affected by the Sudinokibi crypto virus that stole private information like date of birth, credit card numbers, and so on, and ransomed Travelex for £4.6 million. There's been a few other attacks as well over the years, some that we know, like WannaCry or NotPetya ransomware that encrypts your data. And in most cases, these crypto viruses, even though if they tell you, oh, you can pay money and we will send you a key to uncrypt it, that doesn't work. WannaCry cost the UK National Health Services £92 million, and 19,000 appointments was cancelled due to the ransom attack. And of course, who cannot forget one of the most famous ones, spread via a Ukrainian accounting software, where the Danish shipping company Maersk and a bunch of other companies around the world got hit. It hit Maersk with full effect. It locked every single server and computer. The only unaffected machine was a domain controller in a branch office in Africa that was offline due to a power outage. And by not reconnecting that to the network, saved them the pain of recreating the entire domain. It took Maersk up to a year to be back to 100%. And there has been many stories like these with hosters, regular companies, and government agencies. No one is safe. If somebody clicks on a link that comes in an email, on a website, or any way into your computers. Users don't always have the best knowledge. We as IT pros need to secure our environment and data from accidents like this. So, what do we need in an isolated Fabric domain? Well, we need some domain controllers, either some separate DHCP servers or on the domain controllers for allowing us to provision IP addresses to new machines, physical hardware that where you can set IP addresses for BMC, IDRAC, ILO controllers to get remote access or console access to your physical host. A PKI infrastructure so that we can provision certificates for RDS, Windows Admin Center, and other things that require a certificate. We need some RDS servers with RD Gateway and an RD Web installed so that admins can log on to a desktop and normal users can use web apps in the RD Web console. I'm also a very big fan of Virtual Machine Manager, so we always do our Fabric domain with VMM to easily manage your host and virtual machines. And of course, SQL is a part of that. Since we are on the System Center part, we also prefer to use SCUM as our monitoring tool to monitor the environment. The reason for this is because it has so many management packs that automatically set up your environment to give you alert to use, alerts via email, SMS, and the other solutions it has. But you can also use any other monitoring solution you want. We also recommend setting up a WSUS server to provide some kind of control over your patching. You don't want patches to be installed at 9 a.m. Monday morning. And yeah, so you have to approve your patches. Management servers for hardware. There are some vendors that has management servers to like Lenovo xClarity, Dell OpenManage, and so on. And least but not least, we need a backup solution, something that backs up your infrastructure. Your Hyper-V host with your virtual machines, your Fabric VMs, and your Fabric hosts, so that you, in case of an emergency, you can restore. So let's start with designing. So the really important thing here is to have dedicated hosts to run the Fabric infrastructure. Do not place them on a cluster, because the cluster requires the main controller to be running to get the cluster to start. So always put at least your domain controller on something that is not dependent on the domain controller to start, because Hyper-V starts as a standalone without domain services running. So that's really important. And as minimum, we always do two Fabric hosts, so that we can spread our services across the two hosts. And for those services that are high available or redundant, like domain controller, DHCP, certificate server, and stuff like that, we can then spread those over the different physical hosts, so that we always, if one is down for maintenance or something like that, 50% of what we need is still up, and we can do our management stuff. And another good thing is to leave enough resources on both hosts. So if you know that, hey, I'm having issues with my host, let me move everything over to the other one, and then I can investigate what's going on. You need enough resources like disk and memory and CPU to be able to run those on the machine. And the way we design our host is basically we design them with a 1U a Lenovo server, an SR630 with like dual core, with dual 8-core CPUs, 192 to 384 gig of memory, and about 2 to 3 terabyte of usable disk space. And of course, your NIC of choice. It could be 10 gigabyte, it could be 25 or 100 gigs. And yeah, so this is basically the configuration. And as you can see here, we've spread our resources over the two different Hyper-V hosts for the Fabric. So what does a Fabric domain need? Well, it needs some separate subnets, like a Hyper-V management subnet for the Hyper-V host. And if you're doing cross data center traffic, like SDN with BGP and so on, you will need more than one subnet if you have multiple racks and multiple top of the racks where your Hyper-V hosts are in, because the traffic then is routed. You will need a Fabric subnet for your Fabric servers, an out-of-band subnet for console access to the BMC, IDRAC, ILO, or whatever each vendor calls their console access. And you will, of course, also need a separate backup subnet. The subnets should be routed at the core switch level with access lists, if needed, between different subnets. And if it's not spanning more than one top of the rack pair, it can be routed on the top of the racks. You will need a transport subnet up to the firewall for any in and out traffic to keep the rules simple on the firewall. This will allow you to just have one interface in and one rule, basically. Only allow HTTPS traffic from the outside to the RDS server. Limit the traffic to just jump server. That way you minimize where access can be reached from, because the RDS, either if it's the RD gateway or the RD web, uses HTTPS and port 443. And of course, also limit outbound traffic. Don't allow your Hyper-V host internet access if you don't need it. Give the RDS server access via HTTPS to certain services, or to be able to download patches, download firmware, drivers, and so on. Allow your WSUS server to be able to reach the Microsoft Update services. Allow any vendor management server access to their services to be able to download firmware, drivers, or what it needs, or any call home features or something like that. And if you, of course, have hybrid features running, then you will need access to those hybrid features. So you might need to enable access for those in the firewall on the outbound ports. Yeah. If you want to protect your entry points even further, you can enable Windows Defender ATP on both the jump server and the RDS server to alert and protect your solutions from attacks. Dave Kavula and John O'Neill Sr. has a session today as well about Windows Defender and Azure Stack HCI. So you can learn how to configure and set up Windows Defender from that session. So the most important thing with a Fabric domain is to keep it simple. Don't overdo it. Keep a simple AD structure. Don't overdo group policies. Keep it simple and minimal. And just basically just set up the group policy objects you need. And for God's sake, do not import your group policies that you're already running in your domain. Create new ones and remove all the bad stuff from there, because you do not want to lock down your domain, your Fabric domain, the same way you do your normal domain, because this is already secure. So keep it simple. That's it for that. Don't use domain admins on your normal users. Use separate accounts that you use to run programs as a domain admin, to run PowerShell. This way, if an attacker should get in, they don't have domain admin rights on your Fabric domain. They will have to work for it. And if you have Windows Defender ATP, it will alert you before anything happens. Create secure and complex passwords. Use LAPS to secure your local admin passwords and to protect from local access attacks. And of course, don't use password 123 or summer 123 or something like that. And if you want, you can also use KMS to automate activation of VMs and hosts in your Fabric domain. Certificates. I also recommend setting up a PKI solution in your Fabric. It can be as basic as you like, but always create a separate root CA that is not part of the domain and which is always kept offline. So if something happens, somebody messes up something, you can always recreate it from the root CA that is not online or a part of the domain. Create a sub CA where you will that will be the main certificate provider, and also create a second one as a backup in case the primary one has an issue. So it doesn't take you that much time to be able to issue new certificates. And also create a domain computer and IS templates and have that deployed and enrolled via group policy. RDS servers. They are very, very important. They will be your main access in, either as an admin or a user that only has access to things like VMM, Windows Admin Center, SCUM, or any other monitoring tool that you're using via the web console. Do not give normal users console access or remote desktop access into your RDS servers. And we always create 2 standalone servers with all the RD roles installed on each server and all the remote server administrator tools installed. This way there is no dependencies and you don't have to install like 6 or 8 servers to get a high available RDS farm running. and there is no single point of failure, so to speak, on this situation. If one is down, you can always connect to the other, and you will always have console access if you have access to your data center if your RDS servers are down. Always deploy the RD gateway and the RDS web frontend and publish apps when you do this. And like I said, only full admins should have access to the desktop and the RD gateway. And if you're paranoid as me, you will want to enable the network policy server extensions on the RDS solution so that whenever a user logs in, they will need to authenticate with the Azure MFA solution. And of course, use either a domain certificate or get one from a public provider. So, Virtual Machine Manager, it is my favorite enterprise Hyper-V management tool. And I rarely do Azure Stack HCI solution without it, but it happens. We've had a few 2-node installations, and then it is kind of overkill to set up Virtual Machine Manager to manage 2 Hyper-V machines on a 2-node nested S2D cluster where you have 15 virtual machines running, and you maybe deploy a new machine once a year or something like that. Then there is no need for Virtual Machine Manager. With VMM, you should always deploy it as a high available solution with a Fabric domain, and of course place each VMM server on a separate Fabric host. And with Windows, with System Center, you also get the SQL Standard Edition that can also be set up with Always On. So you do have a high available solution, but you can only set up one database per server. So if you have a 2-node SQL Always On, you can actually have 2 SQL databases on the Always On, but they have to be on separate servers to be able to work. And if you want to learn more about VMM and how it works, you can look at my session for last year at the last year's S2D days. The link is in the slide. So just search for MVPDays and yeah, you can find it. Or I also have a blog post, blog series about VMM on my blog, which is 15 parts, and it goes through the basics of deploying and how you should design your VMM infrastructure. And of course, I always install Windows Admin Center. If it's a 2-node simple setup without VMM, I deploy it. If I do deploy VMM with just one server, I install it on the same server as VMM. If I do a 2-node high available VMM solution, I install Windows Admin Center on each of the VMM servers and give it a CNAME that points to the VMM failover cluster resource so that I can always reach it no matter which side the Windows Admin Center, which side that is active. And always give Windows Admin Center a different port, not 443, give it 99999. And another good thing is with VMM, give the bits port another port than the default 443. So we use 8443 as our bits port, which is really important. With Hyper-V and Fabric domain, you need a monitoring solution. Our go-to solution is SCUM. When deploying SCUM, build it high available as well with 2 management servers, a high available SQL server, always on cluster, and of course, again, put them on separate Fabric servers. The reporting server you can only have one reporting server, so you just put it on one of the Hyper-V machines. But it is not a critical thing, it's only for reporting. So And of course, allow SMTP or any other outbound traffic for it to alert you of issues. Now, the good thing with SCAM that I like over other solutions is that it has already pre-prepared management packs with configured settings for monitoring your environment. Everything from AD to Hyper-V to storage spaces direct to even SDN, it can monitor it and give you alerts. A good advice here is not to enable too much at the same time, because you might get overwhelmed by error messages or just warnings or information, and you will need time to tune management packs and create overrides to filter out the different errors that are there. And if you don't know what you're doing with SCAM, get help from somebody that does know what they're doing. Another thing I also put in the Fabric domain infrastructure is the hardware management servers. These management servers manage your servers, switches, and other infrastructure things you have in your Fabric domain. They can access it via the BMC, well, the console access to the machines. Lenovo has the xClarity administrator, which I always deploy with our Lenovo deployments. That has where you can do servers, storage, switches, and you can then do some chassis and rack and resource group management controlling as well. Dell has its Open Manage, and HP has OneView. And these are just 3 examples of hardware tools you can and should put inside your Fabric, your isolated Fabric network, so that there is no backdoor in to your solution. If somebody gets access to this and it's on the outside, they have direct access in to turn off, power off, make havoc of your solutions. And last but not least, put your backup service inside the isolated Fabric, either as part of the domain or as a standalone server, not inside the domain, well, aka a workstation server. Put your backup servers on a separate subnet and make sure that you only allow access into the backup server via the web interface, via HTTPS. And this will then stop any intruders to get in if they get access to the Fabric domain. So thank you for joining this session. I hope that if you do not have a Fabric domain today, that you will think about it, perhaps start planning it, and maybe do it. If you have a Fabric domain today and you're missing something, I might have given you some ideas on how to lock it down even more. So thank you very, very much. My blog site is, of course, jtpeterson.com. Twitter is at @JanToreP. And of course, our Slack channel is not storyspaces.direct.slack.com, but Azure Stack HCI.slack.com. So thank you very much.
So hi, we need to talk about ransomware, and we are going to do that based on some case studies we've seen in the past and that woke up some of the boards and executives to the dangers. So my name is Didier van Hooyen. I'm better known as Working Hard in IT. These are the information you need to find me, and we'll leave it at that. Let's dive in. So the ransomware business model is actually quite a nice one, and it's very well done, which means that you get infected, they'll give you a ransom note, they'll help you to pay, and then you'll get your decryption key, their product, which basically helps you to recover your data. And if you Google around a bit, you'll find some numbers that are pretty sobering. If you look at the rise in let's say, the business revenue that is being, delivered or cost to the market, that's pretty significant, and it's on the rise. Also, the average cost per ransomware event is on the rise. And the damage done by a ransomware incident is also rising very rapidly. So this is a bit disconcerting. Now, If you look at ransomware, it is pretty neat. It is a perfect package. It gives you a ransom note. It tells you how long you have until the payment for your ransom will go up if you don't pay fast enough. What the time is that all your files will be lost forever. They give you some explanation. They give you some links to teach you about Bitcoin and where to buy them so you can pay them, and they have this nice link and you can check if your payment has arrived, and you can even decrypt some files to as a demonstration that they were able to do that for you. So all in all, this is pretty well done. The thing is, once you get hit by ransomware, and you're gonna get hit by ransomware sooner or later, that means that, well, you have to restore from backups. And if we look at backups, then we have a bit of a problem here as well. Over time, the number of people that says that they never back up their computer has gone down. So then you have the people that back up their computer daily or weekly. And as you can see, it's changed a bit over the years, but it hasn't grown significantly big. And then there's the monthly, yearly, or multiple yearly people. And well, let's face it, this is nice that they do it, but that means you could lose 3 or 4 months or a year of data, which is quite unacceptable. And this is what it looks like in a pie chart. So actually the people that have been backing up their data daily hasn't increased 1%, not at all. So all in all, while we are heading in the right direction, it's going so slow that it's not good enough, just not good enough. Now, this is nice to see that, well, for an individual person, but for your business, of course, things become a bit more, let's say, critical. Before ransomware, we had this discussion going on quite a lot. The boss would look at the expenses. Backups is something that takes money, it consumes time, it takes an effort, then you do some drills to recover the data. But all in all, it is not something that contributes directly to, let's say, the profitability of your business. It is more of an insurance policy. And guess what? They cost money and time. And if the money is tight, well, the temptation is or was there to get rid of it. Now, luckily, that is changing slowly. How do you deal with this in your organization? Well, the first thing you need to do is to prevent that you have management that will be perfectly suited for a meme for people like me who talk about backups, right? So if you make bold statements, you'd better make sure you can live up to them. Otherwise, well, you're going to end up on a slide deck of me. So what you need to do is you have to be a functional family. So that means you don't have to have a blame culture, because when you have that, people will just start to avoid failure, but that's hardly progress, and it's certainly not success. And then there's the people that start focusing on compliance, the checkbox culture. We did everything by the book, and we have all green marks on our checkboxes. Maybe that doesn't help you at all, but at least they can say, hey, we did everything you asked, and here it is. The documents and the bureaucracy at least are happy. And then there's a lot of people who have methodologies and processes in place that are actually not really helping. If your change management process makes sure that people patch less or are, let's say, more risk averse to patching, then it is not helping you. And if that process or documentation doesn't give you the tools you need to act in a time of crisis, then basically what have you been spending your time and money on? So what you need to do is create an environment where people feel safe and they can and are willing to contribute. Otherwise, they're just going to hide in work groups or workshops and meetings about the problem so they can show to you that they're making progress. But in fact, they're trying to avoid responsibility and blame. And maybe sometimes if you think about what can happen to your business with ransomware, they're just paralyzed by fear and they want to fix everything perfectly so that threat is taken away. And of course, perfection isn't really possible. And then, so what do? You have to do defense in depth. That is something we have known for quite a long time. Everybody knows this, but still a lot of people fail to do so. There is no single solution to implement. There is no single solution to buy. You will protect everything you have in your environment. Your clients, your IoT devices, your edge devices, switches, servers, your storage, but also your backup infrastructure. And that means your cloud infrastructure and data as well, because whether this is on premises, hybrid, or in the cloud, you you are vulnerable if you don't protect it correctly. Insurance is something relatively new, but you can buy insurance against cybercrime. It helps you pay with the expenses for the recovery cost, the fact that you will have to hire extra people or spend a lot of money recovering your data and getting your business up and running again. You can protect against that. However, insurance never pays the ransom. So it's a bit like acts of God, pandemics, wars, and ransom. Basically, those are not covered. So that's important to know. You cannot insure your way out of this, right? If the data's gone, it's gone. A war chest to pay ransom, it's nice if you have the money to do that, but that comes at a risk, and we'll discuss this a bit later, because paying ransom doesn't always mean that everything is hunky-dory after you've just paid the money. And finally, backups and recovery are key, because no matter how well you are protected, how good your insurance is, how much money you have stashed away to pay the ransom, chances are you will get hit by ransomware, you might pay, you might have insurance, but if you can't recover your data, well, you might be out of luck. Key elements as well are that you have early detection. So you need monitoring. The earlier you know something fishy is going on in your environment, the better. So honeypots can help with that. So you attract some criminals to a juicy target and see very quickly what's going on. And another element is education. So you really need to educate everyone in your organization to make sure that they know how to deal with phishing attacks and let's say suspect documents arriving in mail, that they don't visit dodgy websites, all that sort of stuff. And that goes for everybody. It's not just, let's say, the secretaries or something that you need to train on this. You need to train also your CEO and even your IT personnel, because everybody gets distracted, everybody makes mistakes, and nobody's perfect. So don't forget that. What you also need to do, and that's an effect you will get with defense in depth, is that you will slow them down, which means that you have more time to detect that something is going on and you have more time to respond. It also means that as they are slowed down, because you have defense in depth, is that they can't do as much damage as fast, so the breadth and the depth of the damage will be less. You can also observe what's going on and collect intelligence and evidence if necessary, but the final aim of all this is to be able to stop them before they do too much damage and your business is toast. So ransomware attacks have gone through some evolutions. So in 2015 to 2017, I would say the number of ransomware attacks was really peaking, and it was at the peak in pure numbers. People, especially personal devices, getting hit by ransomware was at a maximum. So that went after file shares, your documents, your knowledge worker data, and as long as you had a backup, that was really easy to recover from. You just wiped your PC and restored from backup. If you could do that, well, fine. But of course, as you've seen in the beginning, a lot of people still don't do daily backups. Which is a bit of a pity, because it's quite easy to do nowadays, and the tools are out there for free. At a larger scale, of course, if they start encrypting complete file servers or virtual machines, it's a bit more challenging, and the disruption to the business becomes a lot bigger. And what you also had is, even in the early days, you could pay, and that would lead to, let's say, a satisfactory result or not, meaning either you got your data back or you didn't, because paying doesn't always mean everything is hunky-dory. The last few years, we've seen that the sheer number of attacks isn't as big anymore as it used to be, and it's not as rising as fast. What we have seen is that they become a lot more sophisticated. So the spraying and praying and going after the easy targets those days are a bit over. The trend is towards targeted attacks, where they really reconnaissance your business, they find out what you have, and when the moment is right for them, they strike to maximize their profit by maximizing the damage to you. So this becomes highly sophisticated, which means that they could be in your environment or network for weeks or months before you even notice or get hit by the ransomware. They also have, let's say, a better business model. They have professional service desks. You can call them with your questions. You could even negotiate a bit if you want to, and they'll tell you this is how low as we can go, and that's it. You pay or you lose your data. So it's not really that you can drag this on for months and months in the hope to get a better deal. But in the end, the real professional criminals, they see this as a sustainable business model. So they want to be reliable. They actually want to help you recover your data because that proves, hey, if you pay us, we deliver a result, and that's what a customer wants, right? Between brackets. They also play a bit the Robin Hood. They try to be socially responsible. They have educational goals, so that means that, well, you might not have realized how important your defense in depth was or what the weak points were in your environment. Well, now we have demonstrated this for you. We've shown this to you, so you have now graduated from the School of Hard Knocks at our establishments, and thank you very much, and this is the bill. So it's a very expensive education, so to speak. They also become a lot better at covering their tracks, which is important to them because, well, they're criminals and people tend to search out criminals and bring them for justice, and they want to avoid that. And what's also very nasty is that, well, they look like ransomware, but they're not, and those are the wipers. So the wipers are actually a threat to the ransomware business model because they are not interested in ransomware, they just want to create damage, which is pretty bad. Sometimes they look like they want a ransom, but actually you can try, but normally that doesn't even work. And even if you send some money, you'll never get a decryption key. They're just not interested in that. They just want to do damage. The wipers came into the view, the public view, with the big name attacks, like Maersk was one of them. And what actually happened is that this was based on a known ransomware. They used the same bits, at least for a big part, but this was an attack from a nation state against another nation state, Ukraine. So you can guess who probably the attacker was. But the initial vector was a software update from a Ukrainian accounting software company, and that company basically had been compromised. So the signed software updates out of that company that went out to the customers were completely trusted, but they contained the payload. And in the end, this is what it looks like if your industry or nation gets hit by ransomware or a wiper. This is a shop, but this could be a hospital, a bank, a factory, your office. It's pretty chaotic, and basically your entire business grinds to a halt because nothing works anymore. Now, there's two very big important things about this example of a wiper that you need to take away from this. Is this: it was collateral damage, because in the end the focus went to the big companies like Maersk or Merck or FedEx, all those, because together they accumulated billions of dollars in damage. But those were actually never the target. It just spilled out of the Ukraine because it contained other backdoors to spread. So these companies were not using that Ukrainian accounting software. No, they were just, yes, unfortunate bystanders, so to speak, but at a considerable cost if you look at the numbers. So what happens? Well, they were not in Ukraine, they were not using the software, but they hadn't patched against a known vulnerability, Eternal Blue or Eternal Romance. Those are exploits that leaked from the NSA. They had them in their pocket for quite a while. They leaked. The entire cybercrime industry, they jumped on it. Microsoft brought out patches, and if they had patched a couple of months in advance, they probably would not have been hit so bad. But they didn't. So what do we learn from this? Well, even if you are not the target, you can be hit. And if it's not a ransomware player, but a wiper, you're really out of luck. You need to recover from backups. But you can avoid it by keeping let's say, a good security stance and patching. And the other thing that is pretty disconcerting about all these examples is that most of them survived by luck. They had backups, they had some processes, and they had a plan, but you know how they say it. Everybody has a plan again until you get hit in the face, right? Then it's all of a sudden, what's happening? I didn't foresee this. This is not my plan. Of course not. Your adversary doesn't work with your plan. It doesn't care about your plan. And what really struck me is that Mark survived by sheer luck. That is, they found one good copy of a domain controller in the world, and they only found it because that domain controller happened to be offline due to a power failure at the time that the ransomware struck them. And that's kind of painful to realize that large companies with a professional IT infrastructure basically were able to recover with luck. But Maersk and NotPetya are not the only one that are running around. These screenshots here are from my country, and what you can see here is a factory that builds weaving machines. These are people in the aeronautical sector, and they're all struck by Rook, which is a bad one that is going around targeting verticals like factories, manufacturing, or hospitals at the moment as well. But there's plenty more, and there are so many going around in different parts of the world, sometimes targeted at specific nations, that it's not fun anymore. The serious bad boy right now, in my country, for example, is Rook, or however you pronounce it. But these guys also tend to go after the vertical of the healthcare. And as you can look at the picture, a modern operating room is filled to the brim with technology, and the last thing you want to see on the screen is a picture of a ransomware notice where your medical image should be. So the targeted attacks and the wipers, they will always go after backdoors or other more inventive ways of getting in. They will encrypt your data and systems, and they will try to destroy your backups. So it becomes important to defend your backups and your backup storage against people who can get in. And you really need to up that game. So you need to make sure that your backups are not dependent on the environment it backs up and vice versa. They need to be separated from that and protected with extra layers of security to avoid them being destroyed in the attack. As I said, they will delete the backup files. They might even reset your backup storage and appliances to the default settings. That's even easier than deleting your files. And that's why you have to protect those appliances. People should not be able to log into those, even if they find them. The password should be set. You should have multi-factor authentication, that sort of things. And don't forget, wipers do not care about ransomware. They're just out to kill you, basically. So what can you do? Well, prevention. Some people might say, well, prevention isn't perfect. Well, of course it isn't. We know that, and maybe the corona crisis now has driven this home, right? Vaccination, while important, is not perfect. Washing your hands, while important, is not perfect. Patching, guess what? It's not perfect, but it does help. You could avoid so many issues by patching your systems regularly that even if all the other things that are on this list in order to protect your systems, if you don't patch, you might as well not do these, right? This is defense line number one. So before you go into the more complex and the more costly and the more, let's say, operationally expensive ways of protecting your environment, at least do what the bare minimum. MFA is critical because you don't want your credentials to be abused if they do get compromised. And that also means that you have to do your best to protect against that lateral movement in your environment where people get in to the workstation of a knowledge worker and they have time and skills, so they will try to move out of there and go for more interesting targets. What you also need to do is to act locally and think globally, as I like to say it, because by protecting yourself locally, you yourself as an individual or your knowledge workers, but your databases, your network, your storage, your backups, you help everybody. Because all levels need to be involved. It's very easy to get, let's say, a bit discouraged and say, oh, we cannot protect ourselves against the big players. Well, of course not. If you're up against the nation state, if the NSA wants to get into your data, they'll probably be able to do so, and you're toast. But that's not what you are protecting from. You're protecting against ransomware people or wipers out there in the wild that don't even care about you. Because remember, the big examples with NotPetya, they were collateral damage. They were not the target. It just happened to them by accident. So what you need to do is work on everything you do and focus on the progress and not the perfection of your tooling and your results. That's very important. Again, detection. The key thing is that the sooner you detect things, the better off you'll be, because the damage will be limited and it will be easier to recover from it. So monitoring is part of that, and if you don't monitor, you don't know that something is going on, which means that you have to be eternally vigilant, which is time consuming, yes, and it's a bit of a pain sometimes, but it's necessary. The threat landscape today just requires this. And then finally, and I hate to be the bearer of bad news, but you will have to assume that everything you do in prevention and monitoring and detection is going to fail. That doesn't mean that you are a bad employee, that you're incompetent or whatever. It's just reality. That's why you have hospitals and surgeons, because even if you exercise and eat healthy, people do get ill. They do get diseases, and we need help. So this is what we need. We need to back up data and recover it. And recover is more important than backup. You can't recover if you don't back up, but if you only back up and never test recovery, you have no clue if they work. You have no clue how long it takes. So you need to do this. You also must make sure that you have multiple options when things go wrong. You just don't want to have one ace up your sleeve, you want to have a couple. If one option fails, you can try another one. So that gets you to the 3-2-1 rule, right? 3 copies on 2 different media and 1 in a separate location. And one of those could be an air-gapped copy, one that is unreachable physically or logically by anyone because it can't be touched no matter how many credentials you have. That is, let's say, paramount, because if they are really good and they breach to your defenses, they will delete every backup they can find. So you need to have this copy that is untouchable. What you also want is copies in time, because as you know, we have this reconnaissance going on in your environment, and you don't really know how long they have been in there. So you might say, hey, we can restore the data from yesterday, but then perhaps you will be hit again in 2 days. So you need to be able to have multiple copies over time, so you can go back longer in time. But you also want to be able, when you restore backups, is to look at those backups and investigate those backups. Is something fishy going on here? So you have some sort of a sandbox where you can test those before you take it back into production. Otherwise, you're just going around in a merry circle, right? And you restore, you get hit again, you restore, you get again. So you don't want that to happen. So how do you get air gaps? Well, the threat of ransomware today is so big that we, became so afraid we had to look to the past to find protection, and that was tapes. Because tapes, basically, if you take them out of the tape library and you put them in a safe place, even if they have complete control over your tape library, the tapes are not in there, and unless somebody physically puts them in, you're safe. Now, tapes can also be virtual. You have virtual tape libraries, and you can take those tapes offline as well to a cloud provider, for example. But in that case, you need to have something that mimics the air gap, the physically taking the tapes outside of the library. And that is basically immutability, so immutable storage, like S3 Amazon storage has. It's immutable. That means even if you can see it, even if you can read it, there is no way that you can delete it. And that's a hard block. No matter how many writes you have, it's impossible. You can also achieve this with disks. If tapes aren't to your liking, you have more and more disk-based read once, write many solutions that will do this for you. And this is just one example. But of course, instead of relying on virtual tape libraries or physical tape libraries or disks, the software companies that produce backup software has also started to build this into their backup solutions, which means you don't need a virtual tape library anymore, but you can send your copies directly to the cloud, where you enable the object lock, the immutability, and you have that air gap functionality. So you can do it directly now with the backup software. Now, one thing you need to remember when you go to air gapped backups, this will increase your restore times for your backups. Why? Well, if they're tapes, somebody has to go and get them. put them in the tape library, restore them. If they're in the cloud, you have to get them back down to your environment. That might not be going as fast as recovering from your local disk or tape system, especially not if you have all flash systems running that. You might call your cloud provider and let them take off the throttling that they normally have so that you can move a little bit faster. But remember, this is a very different exercise than restoring 2 or 3 VMs. This is restoring potentially hundreds or thousands of VMs depending on your environment. And that is going to take a lot more than you might assume, a lot more time than you might assume. So be aware of that. As I said, paying is an option, but I've written a blog post a couple of years ago about the fact that paying might not lead to the best results. It might just not work. You have incompetent people running around in the business as well. There's nothing to pay when it's when you're dealing with a wiper instead of ransomware. Even when you pay and you get your data back, well, what else did they leave behind in your environment? All kinds of backdoors and tools so they can steal data or extort you a little bit more later. So paying is an option, but it's not my favorite option, and I really try to avoid having to do that. Some people have asked me, hey, why all these ransoms in Bitcoin? Why not use my Visa card? Well, of course, they want to be anonymous. They don't want to get caught by the police. It's fully automatable. They can create wallets per victim, and they can track who paid very easily, and they can keep creating new wallets automatically, so they can't be targeted or found out that easy. So it's very, let's say, it's business wise for them to do so. Also, Bitcoin's transactions, once they're done, they're done. You cannot call your bank and say, hey, hold that order, stop that, retrieve my money. No. So that's, let's say, for them it's an insurance that they get the money. And of course, Bitcoin is very popular. Everybody can buy Bitcoins, so that's something that works for them. And all the other ones, well, basically don't. And why do they use Tor? As said, they don't want to get found out, so Tor helps them avoid law enforcement. They have to keep their websites where they run secret, so otherwise they would be shut down. Again, they leverage botnets. Tor makes it less easy to track those and shut those botnets down. So it's all about avoiding detection and maintaining their business as up and running as long as possible before somebody shuts them down. And the key takeaways here are that you need to assume that a breach will succeed and that you will be compromised. So once you come to grasp with these two realities, you need to have backups, you need to have air-capped copies, and you have to test your recovery so you know what you're dealing with when it happens. And that's something that I want to drive home. Protection alone will not save you. You will have to make sure that you can recover when you are hit, because sooner or later it might happen. And maybe you're lucky and it doesn't, but as we said, luck is rare and it runs out. So I hope you woke up a bit more, if you haven't already, from this talk, and see you again later. Bye-bye.
Hi, my name is Thomas Maurer, and it's an honor to present at this year's MVPDays. In this session, I'm going to talk about Azure Hybrid and how you can connect your Azure Stack HCI or your Azure Stack Hub and so on with Azure Hybrid services to make your on-prem environment even better. My name is Thomas Maurer. I'm a cloud advocate working at Microsoft, and our main jobs are basically creating content, delivering content, engaging with our communities, gathering feedback, what is working for our customers, what is not working, and bring that feedback back to our engineering teams. So happy if you want to reach out to me, please do. You have my URL, you have my Twitter handle. So hopefully if you have any questions, feel free to interact with me during that. So we're going to jump right in here, and we're actually going to have a look at how we're going to, or why hybrid is such a big thing and why it is so important. So if we look at our customer's environment currently, you can see that they're getting increasingly complex, right? So IT operations, IT administrators, they are managing hundreds, if not thousands of applications. And some of them very modern applications built on PaaS, serverless, containerized solutions, but some of them very traditional workloads in virtual machines or even physical servers, running on-prem on Azure Stack HCI, on our competitors, and in other environments as well. And that brings me to the next point. This highly diverse infrastructure. This gets also more and more complex for IT staff to basically maintain this and administrate that infrastructure, right? So companies have probably their own data center locations, they have stores, they have branch offices, they have different OEMs, they have even IoT devices maybe which need to be managed by IT. And then we have customers obviously deciding, hey, we're going to do multi-cloud. Some of them, maybe they choose Azure as their main cloud provider, but they already have another cloud provider in their environment, a department which already started and they're using another one. Or they decide, hey, for this specific scenario, we're going to use that cloud provider because they have a better service, or they are basically like we want to have some sort of flexibility when it comes to cloud provider. So managing all that becomes a lot of effort, and that's we are trying to help, and I'm going to show you how you can actually use Azure services to make your on-prem environment even better. Now, to go hybrid, again, there are many reasons. We obviously had talked a lot about this. There can be regulatory requirements which make sure that some data needs to stay in your country or in your data center, and you can't really bring it into an Azure data center because, for example, you don't have an Azure region in your country. And then we also have like challenges when it comes to networking and latency, right? You want to run services where there is no internet connectivity or no connection to an Azure region, or the application can just not deal with that much latency. And then we also see customers saying, hey, okay, we are not quite ready yet for the cloud, but we want to use the cloud technologies and modernize our applications, our environment, using our own data centers and doing that in our premises under our terms. And so those are all valid points to go hybrid, right? And again, there are probably way more than this, but those are some of the reasons why we see people going hybrid. And then if people decide to go hybrid, there are different approaches to this, right? So one of the hybrid approaches is to, for example, connect existing services you have to Azure Hybrid services. So think about like your virtualization environment, your Windows server, your Linux servers running in your data center, in your branch offices, or even again at other cloud providers. And you can basically go up and connect them to Azure services, right? So you can make sure, hey, everything which is already there, I can basically use that and make it better by using Azure services. The other part is that you might want to deploy something new or new application based on Azure services. But again, you can't move it to Azure. Again, could be regulations, could be network requirements. So you want to have these Azure services in your data centers. And that's what we can do with things like Azure Stack Hub or Azure Arc to bring Azure services to basically anywhere, wherever you need them, right? So this is also very important for Microsoft. If you watched last year's Ignite keynote directly after Satya was Jason Sanders, which is the engineering lead for all the Azure services. He presented in his keynote and he talked about hybrid, and he clearly said that we believe that hybrid is an end state for our customers. So it's not going to be an in-between state until everyone is migrated to the cloud. We really acknowledge that there is a need basically to run services at the edge, in your data center, in your own premises, but again, also in other cloud providers. And that is where we now go with our direction to basically say, hey, we need to help our customers, especially in hybrid environments. So therefore, we offer a couple of different solutions. Again, we have, for example, with Azure Arc, where we bring Azure services to any infrastructure. So you, for example, today you can run Azure data services on any infrastructure. Doesn't matter if it's on-prem or at another cloud provider. If you are in the private preview, you can basically go out and run Azure SQL on your infrastructure you want to. And then obviously we have our Azure Stack portfolio, which you heard a lot about, where we have Azure Stack HCI as our hyperconverged solution, or Azure Stack Hub, which can bring that consistent way of Azure and your own instance of Azure Resource Manager to your location, to your on-prem environment. And then we also count in there all the IoT things we are doing. This can be done by all the IoT offerings we have in Azure, but also, for example, with using Azure Stack Edge and other solutions there. So let's get a little bit more technical and let's go into some of our presentations. So one thing I want to highlight here is I'm going to use a lot of Windows Admin Center in my presentations. And if you haven't used Windows Admin Center yet, then you should definitely have a look at it. It's a free download. It's a web-based management portal, which basically you can download and install in your premises. It doesn't need any Azure connection at all if you don't want to. And you can basically go out and manage your Windows servers, as well as your Azure Stack HCI clusters, as well as your other Hyper-V clusters, if you will. And it basically gives you a web-based UI for things like certificate management, event log, and for all these local-only tools, right? We even have a great solution now for performance monitor, where you get a new web UI with some couple of new features, but still uses the performance counter you all know and use to track your performance. Now, the great thing about Windows Admin Center is that it's basically you don't need to install it on every server. You can install it on one of your systems and then start remote managing your systems. And it uses PowerShell remoting to do that in the background. And again, great solution to manage all of that, but I'm going to use it for one specific point. I'm going to use it to connect Azure Hybrid services. So it's super easy using Windows Admin Center to connect these Azure Hybrid services and then take that advantage of that. Now, that said, everything I'm going to show you, you can also set up without using Windows Admin Center, right? I'm going to show you a couple of different demos and you can use basically everything you want in that. So where does hybrid services come into play? So one of the things where we can benefit from Azure Hybrid Services in a very good way is basically when it comes to disaster recovery and backup. And I'm going to talk a little bit about disaster recovery, and I'm going to show you a quick demo for disaster recovery connected to your hybrid environment. Now, if you look at what our customers are facing, we have a couple of different challenges today with disaster recovery, right? Usually we have some distance requirements we need to get our head around. We have initial replication challenges if you have a very bad internet connectivity. But then the main thing I feel like are cost and complexity, right? So we have a lot of customers paying a huge amount to different vendors for the licenses for disaster recovery. And another challenge is, again, it can be very complex to set up, right? If you have just 2 data centers, it's probably easier. But even then, you need to figure out, okay, where do I replicate what? Do I need to have the same hardware? Do I have all the same flexibility? And so disaster recovery never really has been easy. So we're going to have a look at that, how we can use it. So I'm going to use a company, a fake company, if you will, which we all know and love, called Tailwind Traders. Basically the company in Microsoft which represents everyone and no one at the same time. And the question here really is, how does Tailwind Traders solve their challenges with their current disaster recovery strategy using Azure Site Recovery? And so I'm going to show you a quick demo for Azure Site Recovery. I'm going to show you how we're going to use that on a single standalone Hyper-V server. But again, this can also be a Azure Stack HCI cluster or any Hyper-V cluster. And I'm going to talk a little bit more about that as well. So here I am in Windows Admin Center. And you can see here it's a web-based UI. It's locally installed on one of my management machines. And you can see on the left side I have the tools or extensions as we call them, which is basically the menu to go through. And then in the middle, you can see some information about that server. And you can see here, I'm connected to a Hyper-V server. And if I go down and scroll down, we have a solution called virtual machines. So if I click on virtual machines, you can see here, I get like some information, how many virtual machines I'm running. I get an inventory to see all the virtual machines on that specific server. So if I click on it, I can basically go out and set disaster recovery. So I can go and click on Protect VM. And this will get me into a wizard, which allows me to restart the replication for that VM to Azure. So you can see it already selected the subscription location and the Azure Site Recovery Vault. However, I can also go out and say, hey, I can change, for example, the storage account if I want to use another one or use an existing one. And then I would click on Protect and it would start with the initial replication. However, we don't want to wait for that, so I already prepared app01 here and replicated that VM to Azure. So you can see here, it's protected. And if I click on that link, it takes me to the Azure portal directly to that item. So you can see here my VM app01, it's healthy, it's protected. So I have a good status on that. And if I click on it, I can get some more information on it. So now you can see here again, you get some information about this virtual machine. It's healthy, it's protected. You can also see that the last replication happened 5 seconds ago. And I have a couple of other steps I need to fulfill because when I want to failover. So Azure Site Recovery is very smart. It takes the name of the VM, will also be used for the Azure VM. I obviously need to enter a resource group. It also detects which VM size I should use. So it matches the VM size with an Azure VM size. And then obviously I also need to configure which virtual network in case of a failover I want to use. Now, if I want to failover that VM, I can either use plant failover, or test failover. Again, test failover helps me to test the DR. I don't want to find out that something is not working when I actually need to failover. I can use test failover to run some tests. I can do a failover if I need to. So let's say our Hyper-V server or our data center is down. I can just log into the Azure portal and click on failover, and the VM will failover and start up in Azure. And then we have the last one is just plant failover. That is basically when I know I need to do data center maintenance. I need to shut it down, but I still want to keep the VMs running. In that case, the on-prem VM will shut down. We will have the last replication going on and start up the VM in Azure so we don't have any data loss. So those are the options you have. Again, this is now the single VM view, but you can also call it something like runbooks. Disaster recovery plans, where you can basically build a plan with multiple virtual machines, with runbooks and automation to make sure that everything works great. So what I just showed you was basically a replication from a standalone Hyper-V server to Azure. But again, this can also be larger environments. You can use System Center or other Hyper-V clusters. You can even replicate VMware virtual machines as well, or physical nodes as well. Now, let's go to the next challenge we are seeing. So one of the next challenges we're seeing a lot is update management. And when it comes to update management, customers have all, they need to invest a huge amount of time to do all the orchestration of update management. So they have usually physical servers and virtual machines. They run on-prem or in the cloud. It's Windows and it's Linux. And so that's a big set of stuff you need to think of. And then you obviously want to know, hey, are my VMs compliant with my update policy, right? Do they have the updates actually installed, or what's the status here? So I want to have a view about my compliance state. And then I also want to go out and actually install these updates if I need to. And I want to also schedule these updates so I can basically go out and say, hey, please patch my servers every second week or something like that. So we're going to quick have a look how that looks like for servers which are running on-prem in our data center or at another cloud provider. So for that, we're again taking our example company, Tailwind Traders, and we're going to have a look how does Tailwind Traders ensure that both servers running in the cloud as well as on-prem have the most recent software's update applied. So for that, I'm going to show you an overview about Azure Update Management. So here I'm in the Azure portal. I'm in an automation account and have the update management solution activated. Now you can see here I already joined a Azure VM, and you can see here it's compliant and it's actually working. And now what I can do here, I can go and add another Azure VM if I want to, but I can also go and say, hey, I want to add a non-Azure VM. And then with that link, I will come to the documentation and will explain me how that works. But if I use Windows Admin Center, I can basically just go and scroll down in Windows Admin Center to the update extensions. And here I can manage the local updates on that machine, right? So I could just go and say, hey, install me the updates on that machine. But however, I want to do that at scale and centralized managed. So I want to join that to Azure Update Management. So for that, I click on Update Now. I log in with my Azure account. I select which subscription I want to join. Again, I use an existing resource group because I want to join them to an existing update management solution. It automatically picks the Azure region. It will tell me which I can select which update log analytics workspace and automation account I can use. And again, this is the automation account I just showed you. And then I click on setup, and this will now automatically go out, download the agent for me, install that agent, and then basically connect it to the right Azure automation and log analytics accounts. So after that is done, we can go back to the Azure portal. And if we do a refresh there, we will now see that my WAC machine here, my server, which is non-Azure VM, just shows up and it says, hey, it's not compliant because there's some update missing. So let's fix that and create a scheduled update deployment. I give that update deployment a name. I call it for now on-prem. I select, if it's Windows or Linux, I can then select the machines. Usually in production, I would use groups to do that. I can also use dynamic groups, depending on, for example, tags. But for now, for the demo, let's just select that single VM here. So I'm going to use that VM. I'm going to add this. And then I can go out and basically select the update classifications I want to be installed. I can go out and include, exclude updates. And then most importantly, I can go and schedule that update deployment. So I can select the time and the date. And I just click on OK. And I can also do obviously recurring tasks. So I can say, hey, every week on Tuesday, I want to install patches. And then I select if I want to reboot or not. So reboot if required, that sounds like a good option to me. So now we take some video editing tricks to basically go a little bit further in time to actually show you how that looks like. So if I go to deployment schedule, you will see my scheduled deployment here. You can see it's ready to run. And after a while, if it has run, you can go to history and you can see here that deployment job completed successfully. It took 10 minutes to complete. And if I click on it, I can get some more information about it. I can see here that I updated one machine and installed 3 updates on that machine. Again, I can use that to update multiple machines at the same time if I want to. So if I go back now to my machines, you can now see that both of my servers here are now compliant. One of them running in Azure, the other one running on-prem in my data center or somewhere another cloud provider, right? So that is Azure Update Management. So Azure Update Management really checks the compliance of my Windows servers and Linux servers, both on-prem or in Azure or at another cloud provider. It can go out and deploy and install updates, and then we are basically have a single pane of glass which we can actually go out and manage our updates. We don't need a solution with one for Azure, one for on-prem, one for other cloud providers. We can basically just use Azure Update Management for all our servers wherever they are running. A great thing, by the way, to mention, if you're running Azure Stack Hub, there is also a perfect integration with Azure Update Management. There is an extension. You can deploy a virtual machine on Azure Stack Hub and it automatically joins the Azure Update Management solution in Azure. So whenever a VM is deployed, it can automatically show up there and you can start managing that in that way. So let's jump to the last option here I want to talk about. And this is, how does Tailwind Traders make sure that servers across Azure, on-premises and other cloud providers are compliant, configured and managed in a single pane of glass? So for that, I'm going to show you quickly Azure Arc. And first I'm going to show you the operator side, or the cloud operator, which basically has an overview about all the servers in this environment. Now here I'm in Azure, and you can see here all my Azure resources. Wouldn't it be great if I could see my Azure and my non-Azure machines at one place? So I'm going to select this, and you can see I select my Azure Arc machines. And now you can see here my Azure VMs and my on-prem file servers and my Linux servers running in other cloud providers in the same view. You can see here I can use tags, like for example, like location tags or even cost centers. So let's quickly group them. Group by type. And now you can basically see here I have 4 Arc machines and 2 Azure VMs here. And now I can, for example, go and use tagging as an option to filter. So I use the cost center tag, and let's say, hey, I want to see all the machines for cost center 1001. And now you can see, I can see the Azure machine as well as the on-prem file server, which is in the same cost center. So it gives me a very good option to actually organize my servers. Doesn't matter where they're running. However, there is more, right? So one thing I want to show you is policy. If you're not familiar with Azure Policy allows us to basically configure the Azure environment and set some rules for certain ways. And then we also have Azure Guest Configuration, which basically allows us to manage settings of the operating systems of virtual machines running inside Azure VMs. Now, for example, here I can do an assignment. I'm going to show you that in a bit. I'm going to select the scope. This can then be a management group or a subscription or even down to a resource group. And then I can basically say, hey, which initiative definition I want to use. That's basically a collection of policies. So I'm going to look for, let's say, passwords. So we have one already built in to audit VMs with insecure password settings. So this can go out and audit your virtual machines as well as your obviously on-prem servers for password settings. So I'm not going to do that because I already set this up. And now, if I go to overview, you can see here I get a little bit of an overview, some nice charts here, what assignments I have and how it looks like in the last 7 days. And then if I want to find more, I can go to compliance, and I can see here I have certain initiatives assigned which are compliant, and then I have certain which are not. So let's click on one which I'm not compliant with. And this one audits VMs that are not set to a specific time zone. So I want to have all my servers in a specific time zone. And now if I go down, I can click on non-compliant resources, and I can now see my Azure systems, my Azure virtual machines, as well as my on-prem servers in a single pane of glass, and basically see, hey, those are not compliant with that specific policy. So that is very handy. Again, get an overview about all my servers wherever they are running. Now that was Azure Arc and Operator View. How do we actually do that? And this is a high-level view of Azure management. And no worries, I'm going to show you a little bit what that means. So if you start on the left side, if we're an Azure customer, we are basically interacting with Azure Resource Manager. So we're using things like the Azure Portal, the Azure CLI, Azure PowerShell, the APIs to basically interact with Azure Resource Manager. And the Azure Resource Manager gives us things like subscriptions, log, RBAC, policies, tags, all that good stuff comes from Azure Resource Manager. And until we announced Azure Arc, we basically used Azure Resource Manager to manage Azure resources, right? Makes sense. So what we did with Azure Arc, we basically extended Azure Resource Manager to also do that for non-Azure resources. And today we can do that in public preview for servers. We can do that in private preview for Kubernetes clusters, as well as for data services. And again, it's not just there to replace the local tools in general, but just give you the power of the Azure Resource Manager for servers and systems which are running outside of Azure. So the next question would be, how does Tailwind Traders application administrators manage their servers and make sure that their systems are compliant with? So for that, I'm going to quickly show you a demo. Go back to the Azure portal, and I'm basically going now to Azure Arc. And you can see here, as I mentioned, the free services. So we have managing servers, we have managing Kubernetes clusters or data services. For now, we're going obviously to manage servers. And now you can see here all my on-prem and servers which are running outside of Azure, which are connected using Azure Arc in that place. And if I click on server 2 here, for example, you can see here that it looks like an Azure resource, right? I can basically go and then say, hey, I have activity logs, I have role-based access, I can use tagging, and all that good stuff. Now, I see, for example, here's a tag missing, so I could go and say, hey, and just use the location tag, and this one runs on my Surface Pro, so I'm going to tag it with my Surface Pro. Obviously, you would use a data center location or something like that in production, but just to show you, you can basically use that as well. And then I have things like policy to basically go out and see all the policies which are assigned now just to that specific server. So again, before I had the view about all my systems everywhere. Now I only see the policies which I'm not compliant and compliant for that specific server. So now I can go and say, hey, audit my VMs for insecure password settings. And you can see here that this policy initiative have a certain set of policies. Some of them I'm compliant, some of them I'm not. So let's have a look at one which I'm not compliant. And now I see I'm not compliant with showing audit results for VMs that allow reuse of the previous 24 passwords. So now I could actually go out and I can read a little bit more about why and what that actually means. I can then go and change that manually, or I can even go and create a remediation task to basically fix that setting directly. However, there is more. I can also use logs to basically have access to log analytics, but just for that specific server. Before I had, for example, a view on all of the systems. When I had access to the log analytics workspace, I would see all the servers which are reporting to that. Now I basically only have access to the logs of that specific server. And so, for example, if I want to run here a query for updates to see what updates are installed and what are pending, I can get the update log here and can get that information which shows up here. So now the other question is, how do I actually onboard a system here? So how do I onboard a server to Azure Arc? I go simply to add server. And then I basically have two options. It can be an interactive script, or I can onboard machines at scale using a service principal name. If I don't want to log in on every single server, and that makes absolutely sense. If I have a couple of servers, I just want to automate that process to join them to Azure Arc. So I'm going to generate a script here, which will then install the agent for me. As you can see, I will select the subscription. I will select the resource group. And I will obviously need to select a region. Today we can select 3 different regions because, again, we're in private preview right now. And then I can select, okay, which operating system I'm going to install that. So for us, let's just say it's Windows. I can also go and configure a proxy. So if the server is behind a proxy, I can also configure that. And then I can go out and say already, hey, I want to add a couple of tags. I can do that later, as you just saw, or I can already do it when I join the server and already say, hey, when I join the server, he should already have that location tag, for example. At the end, I can then just review, can download the script. And basically what it does, it just goes out and installs the MSI. It basically downloads it for me, then installs it, and then basically connects my server to the specific Azure resource. So if you want to learn more, check out the following links on Microsoft Docs. I have one link to help you with the Windows Admin Center hybrid services, and the other one how you actually onboard Azure Arc servers to Azure. And then if you want to learn more, you go out and check out Microsoft Learn. With that, I want to say thank you. It was a pleasure to present at MVP Days. Thank you. Hopefully see you in the next one.
Thanks for joining. Today we are going to discover the world of Azure Stack HCI solutions on HPE. Who am I? My name is Daniel Apps. I'm a Microsoft MVP, previously in Cloud and Data Center, and now in Microsoft Azure. I'm a Solutions Architect and the Azure Practice Lead at Vigilant IT in Sydney, Australia. You can find me on the Twitters, usually ranting or going on about something, but yeah, flick us a follow. And when I find the time, I enjoy blogging, and hopefully I can find some more time soon. But enough about me. Let's get into it. So today's agenda is basically these 5 areas. I'm going to go over some HPE isms, some concepts around, in the HPE world. I'm going to go over the tool set, and what I use in my Azure Stack HCI solutions. I'm also going to go over some of the management and the monitoring tools and features that we use. And lastly, going to share some of the configs or how we build configs and some bombs build materials that I've used and have out there, actually up for quotes as well. So before we get into the detail, just a quick disclaimer. This is all based on my opinion and my experience. I'm in no way affiliated with HPE. All right, now that is out of the way. So the HPE isms. Firstly, quick specs. So if you're new to the world of HPE, quick specs is your friend. Basically, every product or most products that they have out there will have a white paper or a quick specs. So how we get to that is we go to Google and we just type in, as an example, we'll type in DL380 Gen 10 quick specs, and it'll bring us to a document. And here we can see an example of a DL380 Gen 10. So a quick specs, and it has all the config options, a lot of the detail around what you can and cannot do, all the components, how they fit together and what is available, and the product numbers, right down to we have all the processors, the memory, all the disks and controllers and NICs, which is sort of like your holy grail of components. So next is integrated lights out. So again, this is for the newcomers to the HPE world. If you're a Dell user, that's equivalent to the iDRAC. I forget what the Lenovo one is, but I don't really remember any of the others actually. So it's the remote management tool. Just a quick shout out to intelligent provisioning. This is essentially the pre-installation environment that you will run when you first light up a Dell server or ML server, and it'll run you through the pre-installation to set the operating system variables, configure the drives, and you can load in the ProLine support packs, which is next to the next point, to install drivers and software. So ProLine support packs, as you've probably guessed, is the source for the packages of drivers, firmware, and optional software and management tools. And part of the smarts that we use to implement these or install these firmware and drivers is called Smart Update or Smart Update Tools. So these are sort of like the critical concepts for deploying and configuring the ProLine servers. So quick specs, remember that one. Quick specs is your friend. Right. So ILO, when deploying your hosts, if you're not going to use the deploy all options, and you just want to be selective about what you put in as far as beyond the firmware and drivers, the HP Lights Out Online config utility is a critical one. 2 components to it. The first one being the command line version. And the second part being the GUI, the user interface to configure your lights out, your ILO settings. It runs on Windows Core, as shown there. So there's no reason for you to not install this ever. It's absolutely critical. You must have it on all your builds. So to touch on the ProLine support pack for a bit. Essentially, there are a couple of ways we can use this. Firstly, if you just grab the ISO or grab the media and you can run it on the local host. It's the simplest methodology. Stick it in, run it, and we'll run the local host guided update. Essentially take you through a guided wizard which will detect the current firmware and drivers, and will install the latest versions for you. You get to opt in and opt out of what you want to install. Alternatively, we can actually run it remotely from a remote server, and we can connect to many nodes. You can connect to one if you want, or you can connect to multiple or node groups, and we can just connect to ILO and deploy the firmware without the software update tools. Or if the hosts have got the software update tools, we can also detect and deploy the specific versions of drivers and the software and the optional software management software if we so choose. All right. So it's going to go a quick demo here on how we use the Smart Update Manager. Now there was the local host option, but here we're going to do it as a remote. So I'm running this from a Windows server in the network. I'm going to connect it to 4 ILOs, a cluster of 4 nodes. And they're already pre-configured. Basically, we just put in the ILO addresses. We're going to scan for those. Once they scan them, we're going to select them, add the nodes, and then it'll ask us to put in some credentials. So we put in the credentials, which will get access to them. It'll also ask us for a baseline. This baseline is basically the update level that comes with the ProLine support pack. In the Smart Update Manager, we can have multiple update levels or support pack versions. But in this demo, we just got the latest one. So we're going to fast forward a little bit of time here. Basically, once we get the node added, we do an inventory. Now, once you do an inventory, basically evaluates what firmware is on the device. We're just doing firmware at the moment. We're not doing drivers because we're just doing this via ILO, so we're actually not touching the operating system. It'll make some recommendations and say, look, these are what you have, and these are the versions that are installed, and these are the versions that it recommends. Just to speed up the process, I'm just going to go through all 4 nodes and get them doing an inventory. So just demonstrating how we can run, be efficient with this. So there are more sophisticated tools. So OneView, which we can do a bit more automation. But in a smaller environment where you've only got 4 to 6 nodes or a one-time deployment, we might not have access to OneView. I'm just trying to demonstrate the efficiency of using this. So in this example, I'm going to update the drivers, firmware on the 1 gig NICs. I know that they're not being used, so I can make that change without affecting the nodes. These are production at the moment. This is a disaggregated storage cluster. So just highlighting there that we can define so it will not reboot the system, or we can tell it to reboot if we want, just so you can sort of preload your firmware and control the reboot process. So that was all fun, and in customer environments that I do a one-off deployment in the SMBs, I'll use that, or my engineers will use that. But for the larger environment, or for my environment, I automate this through a build script. So there's the actual bit that I use. Basically, I have the software packages extracted from the ProLine support pack, installed on a share. Obviously, I've generalized the names there. And then during the deployment, I have a whole bunch of bits and pieces that run, but I've got in my post-deployment script, this is the This is the actual line in my build process. So feel free to use that. You can actually run that from the command line with the drive mounted as well. So you don't actually need to have any automation or anything implemented. You can run that directly off the media. All right. So next we have some management concepts, tools and features for management. First management tool, Windows Admin Center. I'm not going to go into what Windows Admin Center is or how we use it, but what I will touch on is and give a quick demo on the extensions for the ProLiant configurations. So a quick summary on the server extension. Single server context, you can review the firmware and driver versions, status of components, temperature, logs, etc., and much more information there. So it's really helpful. Next, we're going to look at the Azure Stack HCI extension. And as we're just joining onto a cluster, this is a 4-node, this is a 2-node cluster, edge cluster with nested resiliency and mirror accelerated parity. So anyway, so that's why the drive config might seem a little bit odd, but anyway, moving on. Here it tells us at the top we've got the solutions classified as hybrid. So we've got SAS hard drives and SATA SSDs. We can look at the ratios, look at the disks, the quantity, make some models, and we actually again do the inventory. But this is from a cluster perspective. So here we can have one view of all the nodes. In this particular case, we have 2 nodes, and we can do an evaluation of the firmware and see what's available, and go from there. That's actually not going to the ProLiant support pack. That's actually making a call back to HPE. So that's real time. Now there's a magic button, collapse all groups. So I would love to have that in the performance monitor. So Cosmos and Daniel, if you're listening, please. All right, and the help, and actually give a link to the ProLiant support pack and the PowerShell module. So that's just a quick overview of the Azure Stack HCI WAC extension there. So quick wrap up of that one. So cluster context, again, review firmware and driver versions, status components, etc., etc. We can toggle the drive lights, and we have the collapse view. It's probably my favorite piece. So next is OneView. So a quick overview of OneView. So basically it's an appliance. You can run it on VMware or Hyper-V. Basically it's got a whole bunch of automation in there, role-based access with centralized management and monitoring. We can monitor, manage networks as well. We can do storage. Actually your virtual connects, so from your blade chassis, it's really powerful. You can interface via the GUI of the appliance, as we can sort of see there. We can also interface with PowerShell and the REST API. Shameless self-plug there, but I did some work with those a little while ago, and I actually still run that runbook and others runbooks interfacing with PowerShell in my environment. Still got some Blade Fabric. It's super powerful and super easy. The REST API I haven't touched in a long time, but it's there. You can tag your resources, so we can see at the top here, we've got Gen 10 S2D, so I'm filtering based on Gen 10 and S2D tags, which are created to strings, and we can do management there. Also, we can have firmware bundles in OneView. So you can see there, I've got a firmware bundle for my Gen 8 series and the latest for the Gen 10s. So next we're going to have a look at a bit of monitoring. Talking about OneView and whatnot sort of naturally moves into the monitoring space. Now OneView, there is a dashboard we can look at in Grafana. I personally haven't played with this one yet. I'm really keen to. I've got OneView in my environment. I've got Grafana in my environment. I just haven't made this connection yet. Not enough hours in the day, but hopefully I'll get to play with that soon. Because as we're starting to hydrate more things to Grafana, it makes a lot of sense. But I thoroughly recommend you check that one out if you are using OneView. SCOM, if you've still got SCOM, there's management packs. So there's a OneView management pack, there's a ProLiant management pack. Similar things, they give you the same, those top level views. What the ProLiant management pack will do is actually, as you can see there on the left, we've got a breakdown of the components inside your nodes. So you can actually create alerts specifically on those particular objects. So it's quite powerful. But enough of SCOM. I think we're all. Did you know that the former Prime Minister, Australian Prime Minister Bob Hawke, set a world record for sculling 2.5 pints of beer in 11 seconds? That's what's called a yard glass. Late Prime Minister, he passed away a couple of years ago. Legend of Australia. Just before he passed away, he opened up a brewery called Hawke's Lager. Actually, funny story, every year at the Sydney cricket test match, he would be there, and it was like tradition that he would stand up and from his corporate box and hold a beer, and thousands of people would yell at him, skull, 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 and he would scull a beer in front of everybody and they would cheer. Anyway, simple Australians. All right. Last but certainly not least, we're going to have a look at how we config our builds, and a couple of builds that I've actually used in production, or I think I have a tender out there currently on one of them, so we'll get into those shortly. So to do your pre-sales or to do your config tools, there is a not so simple simplified config. That's the link there. It's excessive clicking, but it's very, very detailed. And once you start working out the quirks, it's actually extremely helpful and accurate. I don't use it a lot. I basically give the high-level config, the CPU, the memory, the disk config, NICs, and I send that to to my HP distributor, and then they go about building the solution, and that always works well for me. But it's always fun to have a look at that as well. Another tool for your, I guess, your bigger deployments is the Data Center Infrastructure Advisor. It's helpful for power profiling your racks, for your, and advising your consumption there. So let's have a quick look at that. So here's the actual. You can actually do it online, or you can download it. So I'm just going to give you a quick demo here. So we all agreed to that. You pick your profile. Let's just leave that as default for the moment. What we're going to do is we're going to add a now, firstly, we can add a rack into there. So we can go 14 unit rack. Yep, boom. Let's do that. There it is. Yep, cool. Now what I'm going to do is I'm going to add a DL. Let's just grab a 380 Gen 10. DL 380 Gen 10. Set the position in the rack. What type? We're going to do the 12 CTO. 12 large form factor. That'll make a little bit more sense later. All right. Let's do another one. It's going to be in rack 3. Let's make this a 24 small form factor. Boom. So we're starting to build our rack here. Click on my large form factor model there. I can come into my server and I can build my config. So I got 16 core. Sorry, 26 core, gives me the optional CPUs. I go, yep, great, I'm going to have that one. And I can start building out my profile. I'm not going to go through all that now, but I can put in whatever I need to put in into the chassis. All right, and then we hit save. What that'll do is give you the recommended power output, and then we can configure our second server, or once we've got a config that we like, we can go duplicate. I want to make that duplicate 3 times from there up. Let's go bang, I've started to build out a unit. So in this example, kind of like an Azure Stack Hub, this one, but in this example, if this 24 was a node of a 4-node cluster, I just configure it as I need to configure it, and duplicate it 3 times, and then I can start to see what kind of power consumption I'm going to be there. So it helps you cost profile, helps you, size it up as well. But we can put everything in there as well. We've got switches and whatnot. But yeah, it's a really powerful tool. So when it comes to HPE and Azure Stack HCI, there's a couple of do's and don'ts. Some of these are consistent across other vendors. One or two I don't specifically take too much notice of, but some you actually must follow. So iWarp and Rocky, I think this is a standard one across the board. Adapters with iWarp, so your Chelseas, your Caviums, they must be configured in iWarp. The enclosures, yep. The third point there quite contradicts a lot of the build bombs that I get from HPE. I think the Azure Stack Hub solutions actually uses SAS Expander. I've got many builds out there with the SAS Expanders, and I don't see any issues. I get super low latencies and awesome performance. So if you're getting that nth last 99th percentile of performance, then good on you. But yeah, I don't avoid SAS Expanders. I think they're not a problem. I might be wrong, but that's me. So with the controllers, if you've got up to 8 disks, so S2D disks, meaning your cache and your capacity, you can use any of the controllers. Well, I'll specify that later. But any more than 8, and we need to use the 816 if we want to have it all directly on the controller. Otherwise, we need to use the SAS Expander, and I'll explain what those numbers mean soon. For the OS boot drives, they use an onboard S100 controller. It's just like a software RAID kind of thing. Works perfectly well. It's just like an onboard SATA controller. Think of it that way. The smart array controllers, they can be HB or RAID or mixed mode. They must be in HBA mode. They can't be in mixed mode, meaning you can't have RAID drives and HBA drives. Even though that is a supported function from HPE, it is not supported for Azure Stack HCI. So that's never been a problem because my boot drives are always on that onboard controller, and all the other drives in the enclosure are always in HBA mode. But just keep that one in mind. All right. Now, as promised, we could break down the storage controllers and how they what the names mean. Firstly, if too long don't read, E208I A. This is your friend. This is the one that I use the most. It is a 8-channel and means that if I have more than 8 drives in my configuration, so if I have 2 cache and 8 capacity, then I will need an expander. You can have multiple controllers, but I prefer to just use the expander. Just how I do it. To help you with the coding of with the controllers there, that's how you break down the names. So we can see here the E28I is the essential 200 series with 8 SAS lanes internal on the Type A modular controller, basically just on the motherboard. But the other one that we mentioned before is the P816I. So that's their top end. So that's the 8 series performance RAID controller with 16 lanes, internal. Yep. Cool. Cool to boot. Right, with the default configuration for DL380s is they will have in their standard riser, they will have 2 times M.2 slots. Now they'll be connected to that S100i. So that allows you to just fill it up with the disks that you need for your storage spaces configuration. So your cache and your capacity, or your capacity if it's all flash. If you need to replace that riser, in some configs where you can replace the riser to, instead of be PCI at the back, to be disks, then you'll need to have a that M.2 card, PCI card shown, the half height, half length M.2 kit. So that way your boot volume will be on the PCI bus. Long story short, use the default config. M.2 on the PCI riser. Done. Networking. Right. If anybody knows me, I am a Mellanox fanboy. So for the configs in HPE, the 640s are the Mellanox. So you'll see two numbers floating around: the 640 SFP28, that's the PCI; the 640 FLR SFP28, that's the FlexLOM, so the LAN on motherboard. Most of my configs have those two. Two for the 4 ports, 2 for the VMs, virtual switch, sorry, and 2 for the storage, for storage A, storage B. You can get caviums, so for using iWarp, there's 3 configurations. So the 621 and the 622 are essentially the same NIC, just the PCI and the FlexLOM. There is the 521T, which is a 10 gig PCI, but that's a base T, so it's RJ45. So there is an option there for people with RJ45 who don't have SFP switches. Coming up are some bombs, some bill of materials. So the first one is a prod bomb for my disaggregated storage. Most of that, the cores and the RAM are basically idle. But that's a prod today. It is an older bomb, so a lot of those parts aren't available. But just in the interest of openness, I'll share that. It's actually on my blog anyway, but you can see what that is. Additionally, I've got some customer bombs there, some various configs, 2-node hybrid. That's the one I demonstrated earlier with the nested resiliency and the mirror accelerated parity. Got a 4-node all flash, a couple of 6 nodes. That last one, the 104 core, 1.5 terabyte, the big beastie one, that's actually an identical config for using Azure Stack Hub, which works really well. So I'm not going to go through all the details of these, but if you can download the slides, download the video, feel free to use them. But that's the one that I've got running in production now for my disaggregated storage. That's the 2-node. That's an all-flash configuration. Still not sold that all flash is required, especially with storage spaces direct in the cache. We've got a blog I wrote about that a couple of years ago. As SSDs get bigger and cheaper, makes more sense. But there are other arguments. But yeah, anyway, just an opinion. And there's another couple of configs. All right. Did you know? The first police force in Australia was made up of the most well-behaved convicts. How Australian is that? Proof that HPE is reliable. This is a 4-node cluster. This is a storage cluster. This is my production storage. That's some uptime there. So proof that it's reliable. Been running without glitch for that long. And proof we haven't patched this cluster in a while. It's a little bit naughty, isn't it? Anyway. All right. Well, I hope that was helpful for you. There's a lot to cram in, and I only sort of touch on the top. So there's plenty more to discover, but hopefully I've given you a little bit of extra help to help you succeed in your HPE and Azure Stack HCI journey. Thank you again. My name is Daniel Apps. flick me a follow, check out my blog, and yeah, see you on the Twitterverse.
Yeah, hello and welcome to the session installing Azure Stack HCI with Admin Center. Thank you, Dave, for the kind introduction. My name is Carsten Rachval, and I'm one of the Microsoft Cloud and Data Center Management and Azure MVPs. I'm also a Veeam Vanguard. That's another community program there. What else do I do? I'm the organizer of the German Cloud and Data Center Conference that usually takes place in May in the beautiful city in near Frankfurt in Hanau. This year, unfortunately, we have this pandemic, can't do it. Hopefully next year we are up and running again. And I'm also the co-founder of the German Hyper-V community and the Hybrid Cloud community. And one thing I really love is doing showcasts with my fellow MVP and Vanguard and very dear friend Didier van Houyen. We do showcasts and you find them under hyper-v-amigos.net. If you want to follow my work or my community work, you find my Twitter handle Hyper-V Server, very convenient. And if I don't do community work, I'm the CEO of Rachval IT Solutions GmbH & Co. KG. It's a German-based SI, and we install and train failover clustering, Hyper-V, and a lot of Azure Stack HCI. In fact, that's our daily business. You find some more information at our blog hyper-v-server.de and our courses. I do Hyper-V trainings and storage-based direct trainings under powercourse.net. But let's drive directly into our topic, and that's Windows Admin Center, and especially in Windows Admin Center, the cluster creation wizard. So when Microsoft came out with the last version of Windows Admin Center in October/November 2019, they introduced the cluster creation wizard, and that is something that really helps people who don't have the deep understanding of failover clustering and especially storage basis direct hyperconverged cluster, helps them to set it up correctly. And I really love the cluster creation wizard. So we have, when we start, we have now 6 scenarios. You find them here on the screen. We have, of course, the hyperconverged scenario where we can create a failover cluster, Hyper-V, storage basis direct. We can also create a hyperconverged scenario with software-defined networking. That's not topic of the talk, but you can do that, and you can just install a Hyper-V cluster here, compute cluster, only Hyper-V and failover clustering, also a storage cluster with storage basis direct, and also a standard Hyper-V cluster with software-defined networking, and we have the classic failover cluster where we just install failover clustering. But we will look, of course, into the hyperconverged scenario, and without further ado, we just jump into the demo. This is a very demo heavy session. So I press escape here, and we are now in Windows Admin Center. You see here I have only the Windows Admin Center gateway machine here, and you find the cluster creation wizard under the installed solution, but it is not here yet. So for that and an additional information, 1910, the version that came out at Ignite last year, where Microsoft introduced the cluster creation wizard, had in many scenarios, in many installations, problems to go through with the cluster creation wizard. I personally only got to the cluster validation, but fortunately, around a month ago, they updated 1910 with 1910.2, and now the cluster creation wizard should work. So here is, you see, I have installed 1910.2. So we go to the settings, and under settings, we have a lot of things we can configure here, but for us, important is the extension part. Windows Admin Center is a bunch of different scenarios and extensions, and we find the cluster creation preview extension here under available extensions. I click on it and I choose install. because I have to hurry a bit. I have only half an hour for this presentation. So it's now installing the extension. It's downloading it from a Microsoft server, and then it will restart Windows Admin Center. And now we have it under installed extensions. It will take a moment to show you. So there we are with the other installed extensions. And now we can went to settings, and here we have the cluster creation solution. And I will choose that. And here you have the scenarios I talked already about, and I'm pretty sure that is not all we can expect here. Remember, the cluster creation wizard is in preview. So I choose the hyper-converged cluster. That's the Azure Stack HCI scenario where we've installed failover clustering, Hyper-V, and storage spaces direct. And I click on Create. And now we have these 4, let's say, parts of the cluster creation wizard, the 4 chapters, and every chapter has different scenarios or different screens where we go through while configuring our cluster. So here we see, before you start, there are some prerequisites. We have a network adapter on the host configured with IP on the host that we create, or the cluster that we create, the nodes that we want to create a cluster with have to have a network adapter that Admin Center can reach. So we have to have an IP configuration already. The hosts have to be joined to an Active Directory domain. The cluster creation wizard is not doing that, maybe in the future, but now it is not. And we have to have a user that is a member of the local administration group on the nodes. So here I have my 2 nodes that are data on nodes. I love those nodes. They have 8 NVM each in each node. So here you see there are domain joined here. And let's reload that. They are not in a cluster. I tested this scenario, of course. They are not in a cluster, and I have configured the IP settings, because we can do that with the cluster creation wizard, but it takes a lot of time to give every adapter an IP address, but we will see that. So let's go back to the admin center and we go to next. And first we have to give it an account that has the required rights on the systems. So I have to type my password carefully, and now I go to next. And now I can specify the different nodes, da on S2D3 and da on S2D4. It will check if the prerequisites are installed on the hosts, and we have, you see, we have a data center evaluation edition. The hosts are good. If they wouldn't, we can change that and click on refresh, but we don't have to. So now it looks for the installed features, and Windows Admin Center would install the features. So it wants to have BitLocker, data center bridging if we configure Rocky, failover clustering, of course, the deduplication feature of the file server if we want to do deduplication, Hyper-V, and the Active Directory PowerShell module. If that would be not installed, it will install it, but then it will reboot the nodes, and I'm installing in the moment on hardware, so that takes time and we don't have the time. So I took the liberty to already do that. So everything is fine with the features. We go to next, and it will now check if we had to restart the nodes. That is not necessary because all the features were already installed. So we are finished with this part of the wizard, and we now go to the next one, networking. And here we have also 4 different things. Now it's verifying the network adapters. We have 6 network adapters on both nodes. It said it looks good, okay, but if you want to check, we open this, and you see I have 2 Mellanox NICs on a dual adapter, dual NIC adapter with 50 gigabits each. I will choose them for SMB. I have a 2-port QLogic 25 gigabit adapter. We will choose that for our Hyper-V switch, the set switch, and we can create that with the wizard. And I have 2 1 gigabit adapters here that I choose for my management. And usually you would configure an LBFO team on the 2 1 gigabit adapters, but the cluster creation wizard can't do that for you. So we will configure one of those adapters, and that would be work we have to do afterwards. So I click on next, but here everything is fine. We see every adapter, the same adapter on every node, and we go to next. So now it wants us to select a management adapter where it can reach the system while it creates all the stuff. It's an optional step, and I will not do that. I will just jump over it. And now it wants us to edit some adapter properties. And mainly that's IP. So you see here we have some IP addresses already filled. So I choose to have 2 different subnets for SMB. I strongly would advise that, but that's not topic here. And now I have to give this, now let's see. We don't have IPs here. Let's see if we can go by with. If when we add, you see here, we have to have a VLAN ID on every adapter, and if you don't use VLANs, you can choose 0. So, and then IP addresses must be unique across all servers, and that's not true because 2 of the nodes, don't have an IP address. So I do that by choosing an APIPER address. Let's just do that. 1.2. That's a 16 network, and let's do that here too. 254 1.3. It's also a 16 address network, and let's do that here. 254. Let's choose the 1 here and the 3, and let's choose the 2 here and the 2. And it's again a class B network, and let's do that here again. 2, 3, and 16. So now it says everything is fine. We will not use those IP addresses, but the wizard in the moment requires an IP address. This will be our adapters that are in the set switch, so we don't use IP there, but unfortunately the wizard needs it, and that's a topic that can be improved later. So here under advanced we have some more settings. We can tweak the MTU size, but I don't do that usually, so we can set it to different settings. And if we do software-defined networking, there we can configure an encapsulation overhead. We need that for SDN. SDN needs some more space in the Ethernet packet. So we are golden now. We go to next. And now it will create a virtual switch, or we have the option to do 1 virtual switch, 2 virtual switches, and a 3rd option, but that is not possible in this design, so it will be not choosable. We will see. Takes a moment, and Windows Admin Center is like the Azure portal. So you configure something in the portal, and then you click create or execute, and then it will create in Azure an ARM template, and here a Windows Admin Center will create a PowerShell script and execute that, and in the background, and when it's done, you will see here a successful message, like in the Azure portal. So the configuring of the IP addresses takes a bit, so I can connect to our 2 servers, that you can see them. So here we are. It still thinks it's member of the cluster. That's not true, but unfortunately can't get rid of that. I will try a reload. you see here the IP configuration. And now we went through with the adapter properties and are now in the part of create a virtual switch. And here I already told you we have 3 options for now. We can create one virtual switch for compute and storage together. That's the fully converged scenario where you have only 2 adapters and everything is done over the 2 adapters. So there will be created a set switch. We will use the set switch obviously for our virtual machines, but then we also will create VNICs for the management OS. So for example, a management adapter and 2 SMB adapters. But we don't have to do that because we have multiple adapters in the system. So the Windows Admin Center or the cluster creation wizard recognize that and will not offer this option. Instead, we can create a virtual switch for compute only, or we can create 2 virtual switches, one for compute and one for storage here. And I have dedicated adapters for my SMB traffic, SMB direct traffic, or SMB over RDMA. So I'm not a fan of creating a storage switch on those 2 adapters, a set switch, and then create virtual SMB adapters, because I think that's more software that we don't need. So we use these adapters directly without a set switch in front of it. So we go with the second option, create one virtual switch for compute only. And now we have to specify which adapters are for the compute/set switch. So I choose the 2 QLogic adapters on both nodes. And if I don't choose it, the same adapters on both nodes, there will be a warning down there. And if I click this, the warning is gone. Then we have some more options under advanced. For example, we can specify the switch name. Here it's compute switch. We will leave that be. You can specify, for example, another switch name, but I stay with that name. And then we can choose the load balancing algorithm for the set switch. And there are 2 options, Hyper-V port and dynamic. And Hyper-V port is a recommended one. It was changed in 2016 throughout the availability of 2016. I know usually it's dynamic if you create a switch, but Microsoft recommends Hyper-V port now. Then we have other options. This switch uses embedded teaming, so it's a set switch. SRIOV is configured, and we have VMMQ enabled. So don't turn this off unless you have really problems with VMMQ, and we are not in the area of 2012 R2 anymore. There was a lot of trouble with VMMQ, but these days are over, and I always tell my students in my courses, if you turn off VMQ in your host, it's like owning a Ferrari with a stick, and you are only allowed to drive in the first gear. Imagine you are on the German highway, you can drive 250 or more, and you are only allowed to use the first gear. And so a little Polo, a German Polo is coming from behind, and you have to make place with your Ferrari. You have to turn over to the right and let the Polo overtake you. And this is like if you turn off VMQs, you don't have network power in your switch. So don't do that. And there's a nice webinar I've done with Dan Kohumo from Microsoft, and he explains in this webinar why VMMQ is very important for the switch. So let's go on with the creation of the switch. It takes a while, so I could tell the story here while we wait, but unfortunately I didn't. So we wait a moment, and we can now go to the host, and here you can open the Hyper-V manager. And I will also open the failover cluster manager because we don't have a cluster yet. Server manager is wrong. If we would have a cluster, I can connect to cluster. Yeah, it says da on cluster 2, but it will not find it. So we are here in the Hyper-V manager. We can go to switch management, and we see we have the compute switch already. And if it's a set switch, you can't configure the set switch with the Hyper-V manager. So that's a good sign. We can't do anything here, so that we see here we have a set switch. and we can't find the cluster. Okay, not yet. We go back. So we are now done with the networking part, and we switch over to the clustering part of the cluster creation wizard. And there are 2 points: validate, and we start the validation. No, we go back. We want the validate, checking a few things. It takes a moment, and we validate it again because I've done it before. I set it up a cluster here just to see if it works. It's always bad if you do a demo and you didn't have checked it. There can go so much wrong with a live demo anyway, if it worked or not. But if you go unprepared and haven't checked the stuff, that's very funny for the viewers if you are rambling about all what should work, but it doesn't. So we do the validation. The validation is saved in the local directory, so he recognized there is already a validation, so he offered us to skip it. And a word of advice: if you create a new cluster, always validate the cluster. And this is very nice, but let's talk a bit about the validation. Usually, if you do a validation in the failover clustering, you have to choose not all options for a storage spaces direct cluster. You have to choose, I want to choose what is validated, because the storage spaces direct validation part is not included in all options. And that, of course, is weird. So here in the cluster creation wizard, they have it done differently. We have validated it, but we can't see the validation because it's already there. So if we do a new validation, there should be a possibility to download it. I've done that before, so we can't see it here. But what would you see? You would see that the cluster has done 3 parts. It checks if the cluster is possible, but it will not check the storage spaces direct part here. Like it would not do that if you just go with the default options in the failover cluster. So we will come to that if we go to storage. So for him, so for the cluster creation wizard, for it, everything is fine. So we go to next, to the create cluster. And here we need, of course, a name. On cluster 2, I choose the same name I had before. And then under advanced, you have different options. So if you just go with this and don't go in the advanced part, the cluster computer object will choose a DHCP address, and this is recommended, and this is how Azure works. But I like my cluster to have a specific IP address, so I choose that here and I give it one. Then I have to click on add. So now we have an address here, and we can also specify which networks the cluster is allowed to use for the communication. I choose all of them, and I now go to create cluster, and that will take a moment to create the cluster. So Microsoft separated the cluster validation part in cluster, and I assume this is because we have different cluster creation scenarios. We could only create a cluster, or we could create a cluster with storage spaces direct, or we could create a compute cluster with SDN. So different cluster test scenarios. And so they split it up, the normal cluster tests and the storage cluster tests. We will do that a bit later. Hopefully, because I've already done them too. So I don't know if it offers us the storage validation. We can do it again, but I don't know if we can see it if we revalidate it like we had in the cluster part. So this takes a moment, yeah, creating the cluster. Time to go back to our nodes. We don't have the cluster here. And if we then have the cluster, after a minute, also the failover cluster. So now it's created, it's successfully. So when you're ready, we can skip the step and go to next. And now we are in the storage part. It's discovering the drives in the moment. It will show us the drives, but first let's go back to a node. And here we now see we have our cluster. When I click on the cluster, the failover cluster manager opens here, and I'm connected to the cluster. Of course, we don't have any storage, but we have our networks. Yeah, as it's usually done, we have our nodes. We don't have a witness, but we can take care of that later in the admin center. Go back to admin center here. So now verify drives. It checks all the drives and it find 9 drives that it could use for storage spaces direct. There is one SATA DOM drive in there and 8 NVMEs. And the cluster wizard is so clever that it will not take the SATA DOM drive into the cluster into the storage pool. Yeah, so we are fine here. I go to next. We have the same amount of drives and the same drive types in every node. And now, nice thing, we are now able to clean the drives. And that's very important. If the drives were ever used in another cluster that is not probably cleaned up, some drives would have the information about the old storage space direct setup, the storage pool, and we would see a lot of drives here. So I click on clean, and there is a script. If you don't use that, there is a script. If we go here to Windows, to the IC, PowerShell IC, in the Microsoft documentation, there is a script. I destroy spaces. Look in the documentation. Usually you have to run this to clean up the drives. And I think it's much more convenient to just say clean drives here. So I go to next here. And now it validates the storage spaces direct part. So this is the cluster validation, now doing the storage spaces direct validation in the cluster validation. It will take a moment. That's complete already. That's nice. And here you see everything is golden. We can download the report here. That's missing on the cluster page. We can open it and we see that's a failover cluster validation report. All the parts that are tested with the storage spaces direct part. Everything is green. Fantastic. We go back here. Now we go to next. And now we can enable storage spaces direct. If we have caching, we can choose if we want to use caching devices, if we have different types of drives. We don't have that here. And if we have caching device, we can choose if it's an all-flash setup, so NVMEs and SSDs, for example, we can choose how the cache is used. Usually it's used as a write-only cache, but we can also switch to read-write. I wouldn't recommend that. I like the idea of a write cache in storage spaces direct when you have flash drivers, because flash drivers, usually the capacity drives, are fast enough for reads, but you can really use the double the size of the write cache. And so we are now enabling storage spaces direct, starting the health provider already. And I see I'm nearly done with my presentation. So let's finish the presentation and then come back to the demo. So where to find more information? My blog is hyper-v-server.de. I usually blog in German, but you can use a translator, of course, to read my contents. The Hyper-V Amigos you find under hyper-v-amigos.net. And if you want to see some recordings of CDC Germany 2019, where also Dave was presenter, and many other people like Didier, Jaromir, and so on, you can go here to cdc-germany.de/cdc-2019. So I already thank you for watching, and now we go back to our spaces. So it's done. We have another report to download. I will not do that. I go to finish. I go to the connection list, and here is our cluster. And now we have to do some things. For example, assign a witness. There is a possibility in Windows Admin Center now to also assign a witness. We go to settings here, and here's the witness part, and I copy a path here. So witness, we can choose between the witnesses. Be aware that the disk witness is not really supported. So, and I have to type again a user that has the rights to connect here, and I hope I didn't did an arrow here. Yes, I did an arrow, unfortunately. But you can do other things here, configure live migration, configure a witness, go to storage pools, and so on. And you can create volumes here. You see the drives and everything. So thank you so much for watching my presentation. Thanks, Dave and Crystal, for giving me the opportunity. And back to Dave.
Hello, everyone. In today's session, we will take a look into the Azure Stack HCI with Grafana. It's a WSLab scenario. So if you don't know what the scenario is, I'll just show you. My name is Jaromir. I'm a PFE in Microsoft, and I'm from Czech Republic. First of all, I would like to thank Dave for having me here. Thank you, Dave. So this is for the third time I'm here. I'm really glad that I can present here because I think these tools can help a lot of people, and I'm really passionate about this. So let me just show you what you will learn here. So first of all, I want you to understand what scenarios are. So in WSLab, it's not only about a script that can do some machines. It's more or less about things you can do with these scripts and about the scenarios where I describe how to use PowerShell to set up some infrastructure. In this case, we will set up Grafana, and not only like install Grafana on one server, we will have multiple servers, and we will even do it using I would say best practices. On the left, you can see what will be deployed. You can see multiple servers here. We will walk it through. And on the right, there's a result. Result is a dashboard for your S2D cluster. You can then customize and you can scale however you want. So let me first talk about scenarios. If you'll navigate into the WSLab by just typing WSLab into your browser, into your search engine, the first link, hopefully, will be a GitHub page, where if you'll navigate into the scenarios folder, as highlighted here on the screenshot, you will get into the folder where there's a lot of folders, and there's like 50 folders, and each folder is a separate scenario. So let's take a look into this one, which is S2D and Grafana. You will basically start with DC and your Azure Stack HCI infrastructure. This is basic WSLab scenario. As a prerequisite, you will set up S2D hyperconverged scenario to have some infrastructure. I changed there one parameter, which is to use real virtual machines inside, not just fake ones. I will also set up one machine for the management, which will be Windows 10, and all management will be done from there. You will build a cluster from there, and you can also build entire Grafana scenario from here. You will then have certification authority, Grafana, and InfluxDB. So what you will set up, so there will be a telegraph agent that is sending data to InfluxDB. However, the telegraph agent is sending the data over TCP/IP on port 8086. I didn't actually study how it is doing. I didn't study if it's using plain text for sending the password to the database to authenticate to the database. I don't really know. Therefore, I decided to secure this with the IPsec, with the Windows Firewall actually. So Windows Firewall will be configured to accept connections only from S2D agents, from S2D telegraph agent, and also only from Grafana. And then I will be connecting from management machine to the Grafana server on HTTPS. So then, therefore, you need to have a certificate. The certificate will be enrolled from certification authority, and to authenticate you, we will use LDAP. However, the LDAP will be also secured with a
LDAP-S. So you will also need to have certificate in DC. Therefore, that's why we have certification authority in here. So let's take a look what we actually have on my machine. All of this is running on my laptop here. So let's take a look at my Hyper-V manager. You can see I have several machines here. You can just see that there's like S2D cluster with each node has 4 gigs of memory. It can be even less. I'm using nested virtualization. There are VMs running in there that are nested. So therefore I decided to choose the bigger version of the workshop, of the machines, where I have 4 gigs per each S2D node, plus I also have management machine. These machines management is optional, and these machines can have dynamic memory, and it can be much less. All of this deployment finished in 8 minutes. So you have this basic infrastructure in 8 minutes. You will then start all your machines. You will then log into management machine. And in this management machine, what I did, I run S2D cluster, S2D hyperconverged scenario. So basically I did copy this script I got from the scenarios from WSLab. It's S2D hyperconverged scenario, and I pasted it into the PowerShell. As a result, in 37 minutes, it's somewhere between 30 and 37 minutes, depending how your machine is loaded, you will get your S2D cluster fully configured with machines running. And that's because I choose that I will have real VMs here as a parameter. It's here, real VMs equals true. It asks me for the parent image from parent disks. I provided it the parent disk from Windows Server 2016, and when I create it using create parent disk script that you can find in the parent disks folder, I decided to build a nano server image, which is really good because it's really small. So for the lab environments, you can run multiple machines, and actually you can see this machine has memory demand around 235 megs, which is really small, so you can fit many machines like this. Okay, there's one bit. If you want to create these parent disk, you can navigate to your parent disk folder, and you can just run this script, create parent disk. You will provide it ISO file, and as a result, you can have, for example, nano server, or you can have even Windows 10 Windows 10 VHD. You can provide it. You can provide cumulative update, and the cumulative update can be downloaded with this tool, download latest CU. So if you'll just right click, run with PowerShell, you will be asked for what version you would like to download, and then you will have this folder with cumulative update and servicing stack update you can then provide to the create parent disk. So I have several additional disks. There is a nano server. I copied this nano server into the tools VHD, and then I provided it with the script, because you can then find the tools, this VHD in the tools disk in here. Okay, so this is my cluster. This is finished. Then next step, what I did, I also installed Windows Admin Center. So this is from a scenario with Windows Admin Center. I just installed the desktop version. You can just download it and click next. It's the same. This is just 3 lines of code with some comments, and I have Windows Admin Center here, so I can see how my servers are, how are my volumes, and as you can see, I have 4 volumes. It's almost empty. But this is like a fully functional cluster with all the virtual switches, with east-west network adapters for SMB01, SMB02 for SMB multi-channel as a set switch. Everything is here. Okay, so it looks like a real cluster. And now what we will do, we will set up this Grafana. I went for the S2D and Grafana scenario. I copied the scenario script in here in the PowerShell ISE. Let me just quickly go into the IE, into the Edge, and in here I'm in WSLab, in the scenarios, and in S2D and Grafana. There are a few files that are important. One is actually lab config. This lab config defines what you will have in the lab, and if you'll copy these lines and paste it into your
lab config in here, so actually you can compare it, this is exactly the same, then the machines that I have will be created. So basically I modify this lab config, I run deploy PS1, I got my infrastructure like this, and then I logged into the management machine and then pasted the scenario script for S2D hyperconvert. So I have now my S2D cluster configured. Then the next step would be to take a look into the scenario PS1. I usually go and select raw just to have plain text, copy everything, and I paste it into my PowerShell ESC like this. Then I press Ctrl+M. This will collapse all regions, so now you can read it really in easier way. So the next step will be that we will set up my infrastructure. I have empty servers, there are Windows servers, everything is Windows Server, and I like a Windows Server core. You can see it like here, like this. But InfluxDB, if I'll connect here, you will see it's pretty simple. It's just a Windows. It's server core. So what we will set it up from my management machine. I don't want to log in into any machine. I want to do everything remotely. So let me make this full screen. Let me move PowerShell ISE with my scenario script to the right. I will put my PowerShell window to the left, and I will start running each region by region. I will copy just the region with Ctrl+C, and I will paste it into my PowerShell window with a right click. This way I can read the code. I can read what is in the code without expanding the region, or I can just expand the region. I can modify my variables. You can, for example, use this in your lab where you have different names for the machines, and you can just, choose whatever you want and just reuse it the same way as I'm doing here, but in your own lab or even in the production. So this is variables where I define what will be installed where. So for example, what is my Grafana server name, what is my InfluxDB server name, where I would like to have my database, and so on and so forth. Then I will use it in every other region, and this is the way you will basically follow it with me. I'll copy next region. Next region will copy files from the internet. So as you can see, I'm just downloading InfluxDB, Telegraph, and Grafana. I'm also downloading the really useful tool with a cool name that will set up executables as a service. So Telegraph, actually InfluxDB and Grafana will be running as a service. So I just downloaded it. You can check it that it was downloaded into the downloads. You can see all of this purely in the code. So if you will just read this line, it will say, hey, just download it from this address and store it inside user profile in downloads folder. Okay, let's continue a little bit. You can also install Edge. However, since we are on Windows 10 machine, we don't need to install Edge. If I would be running the same script from the DC, then there's only Internet Explorer, so Edge would be really useful. I will skip this one and I will just install management tools. As you can see, there is some logic. Sometimes I include the logic in the script. As I said, these scripts are not for the automation. These scripts are more or less for the documentation. So if you just paste it into the server, you will see how I basically check if this machine where it's running is a server, and if it's a server, I install AirSat management tools. If I'm on the server core, I install a little bit less tools because there's not everything. And if I'm on the client that is older than 1809, I'm checking for the KB, which is AirSat actually in a separate KB. And if I'm on 1809 and newer, I'm checking for capabilities and actually installing the capabilities. Plus, I'm also installing IIS management tools. These are needed because we will need to install and configure IIS on certification authority. Okay, so as you can see now, it's installing all of these prerequisites. There's one thing with IIS management tools. I'm installing it with a DISM, so therefore root feature needs to be enabled. Therefore, after that I'm uninstalling the IIS web server because I really don't want to have a web server. It's either you can click it manually, or you need to also install parent feature plus. Then you need to remove it. Okay. Then let's install certification authority. So far everything was hopefully clear. We just downloaded data, we just downloaded few files into downloads, and we did install some management tools we will then use in the lab. Let's now install certification authority. There is a separate certification authority scenario, but this is almost the same. Basically, I'm just setting up a certification authority as it should be. So I install IIS, I publish CRL there, I'm publishing IL locations and all of these things. What I also do is I'm providing there like a configuration file, so the templates will not be, the default templates will not be published, because I like it. I like to publish my own templates. It's been now 15 minutes. Let me just quickly pause it. This will take around 1 minute, but we have only 30 minutes, so I'll pause the recording. Okay, so installation just finished. Now I pressed continue recording. I will open up Server Manager just to show you that certification authority was installed. So I will add my servers for management. Certification authority should pop up here on the left. Active Directory Certificate Services. I will right click and say Certification Authority. It will open up a Certificate Authority MMC console. And we should be able to see that we have now everything in place. That'll take a little bit of time. Let me minimize this window. And let's check if we have any certificate templates here. There are no certificate templates, so we will publish two. As I said in PPTs, we will have to have a template for the Grafana and also template for domain controller. Let's check it. Now we should have two of them. So there is one for the web server that is exportable. This is a key storage provider, and for domain controller I need to use a legacy crypto security provider because I tried it with KSP but it didn't work, so I had to fall back to legacy. You can see it in here in manage, and you can check it how it looks like. And here in cryptography you will see key storage provider, while in domain controller you will see in cryptography legacy cryptographic service provider. Okay, let's do next step. We need to publish these certificates to our machines. So usually what I do with the code is I prepare it to recycle. So as you can see, I basically say that, okay, if you will modify this table with your other computers, you can type here as many computers as you want with template, as many templates you want, and then use this code as, I would say, as a function to distribute your certificates to the machines. What it will actually do, it will set up security on the template itself, so it will be able to auto-enroll to the machines, and then it will invoke certitude pools, but it will also check if after certitude pools the certificate is present. As you can see, it took 3 pulses on domain controller to enroll the certificate. Okay, so now what we will do, we'll need to set up the file and then run LDFE to reload this file to actually start using SSL for LDAP-S. Let's do it. It's pretty simple. It's just right click with the PowerShell, and now SSL is working on domain controller. And the next step would be to copy NSSM and InfluxDB and Grafana to servers. Let's do it. It's pretty simple. Let's take a look what's in the code. In the code, we will see that we just create sessions to servers and just copy item to these remote servers. One thing I had to do is to increase max envelope size to be able to transfer these files. I didn't have to do this on 2016 servers. For some reason, it's only on 2019. I didn't explore why this changed, but it's kind of necessary. Then next step will be to configure InfluxDB to use something else than program files. So what I will do, there's one extra disk on InfluxDB server. It's fresh. There's no file system. So what I will do, I will first format it. So I will just find the disk where is the raw partition and format it, and then I will create some folders for database that are necessary, and then I will modify lab config for InfluxDB. So there's InfluxDB conf located under program files under InfluxDB, and I will basically switch here this content for a path to my folder. There are some small things that you have to know, like if you will set the content, you need to use encoding UTF-8, otherwise it doesn't work. So these small things make these scenarios really valuable, because this is something you don't have to figure out. You don't have to open it up with a notepad remotely, manually. You'll just, use these scripts, modify it a little bit, because if you don't want to have it on the E drive, you want to have it on the D drive, it's just simply changing one letter. Okay, let's copy this. Soon we'll have our files copied and probably not installed, just extracted into the program files, I would say. So the next step is to configure InfluxDB to be running in E drive. I will format the E drive. I will create a folder structure and set the configuration files for the new folder. What I will do next is to configure these executables from Grafana and InfluxDB to be running under service. So I'm using NSSM with some arguments. So this is actually configuring InfluxDB to be running as a service, and then it will start this service. So InfluxDB should be now running with the database on the E drive. Pretty simple so far, hopefully, right? So this was done. Now I need to secure the communication with the IPsec. So let's try to figure out what's actually going on. So first of all, you need to have a network security rule. So there's a logic. If this network security rule doesn't exist, it will be created. It needs to be created on all machines that are involved in IPsec. So otherwise, the IPsec rule will not work. Then I create the firewall rule for InfluxDB inbound traffic. Next step will be to add into the very same rule I created. I need to add computers that are allowed to use this rule. It's really a bit more complex. You need to set up SDDL string, but with this script, it's pretty easy, because I basically have a list of the servers in this InfluxDB authorized servers. So you can put there anything you want, and you can do it similarly against whatever rule you want. I already figured this for you. Then I will configure LDAP for Grafana. This is really ugly script, but what it's actually doing. it will create some LDAP user on AD, I guess, and then it will modify the configuration file. So there's one region that will configure LDAP authentication, and one that will modify LDAP TOML file. So the logic is a little bit ugly, but if you open up these two files manually, you will understand what I did. The next step will be to secure LDAP to use SSL, because by default it's not using. It's using a simple bind, and this is something you don't want to use. See? So basically, I'm modifying LDAP TOML to use to use root certificate that I request first from the certification authority, and then I create a file, and then I change port from 389 to 636 against my domain controllers. Then I will add a firewall rule to Grafana, because I need to access Grafana over HTTPS. And then the last step will be to push Telegraph agent to my S3 nodes. Okay. Oh, I did copy something I didn't want to. Okay, let me just copy this region. And what this will do, it will download Telegraph configuration file, which is part of the scenario. Let me just show you. So there is a Telegraph conf, and there is also Telegraph PS1. What Telegraph PS1 is doing, it's collecting something you cannot collect with the perf1. You need to run some PowerShell script to create a JSON output file, and then basically push it into the local port where the Telegraph is listening. So you collect some information here, for example, for cluster shared volume, and you then create a JSON file, and then you will send it over to the local port where a Telegraph is listening, and this way you can collect all the data. This is pretty nice trick. I don't remember the guy's name, but this is actually coming from Slack, from S2D Slack, so it's pretty amazing. Also, the dashboard that I will show you soon is modified by Martin Raschendorfer, who created this for his own environment, and we combine it with this script from this guy. I don't remember the name. I should take a note, and this is really great where a community really works, that you merge all of this information together and the result is amazing. Okay, so we have our agents installed. So now, moment of truth, we will open up the Edge, and I'll now navigate to my Grafana server over HTTPS. So grafana.corp.contoso.com. We should see that certificates is here. It's actually from my Contoso root CA. It's trusted. I'll be able to log in with my lab admin credentials. So we should see that authentication works, and it's now hopefully working over SSL to the domain controller. The next step we will do is that we will add our InfluxDB server. It's HTTP InfluxDB on port 8086, and the database is Telegraph. And let's save it and test it. So it looks like our data source is working. So the next step will be adding a dashboard. What we will do, we will import it. And this dashboard is part of our WSLab scenario. So let me just search for it. here's a dashboard JSON. I will click to raw. Come on. Now you should hear my laptop screaming. It's very noisy now. I will paste my JSON, and with this we have our dashboard. Looks amazing, doesn't it? We have no data here. I had the data, so maybe we will just need to wait a little bit because the PowerShell will need to run. However, as you can see, there's my S2D cluster. You can have even multiple clusters. This is something which is in the Telegraph configuration. And with this, it's I'm out of the time. It's 30 minutes, so I hope you enjoyed it. If you have any questions, ask me in Slack or just ping me on Twitter, and see you next time.
Hello, welcome to MVPDays. In this session, we are going to discuss how to bring the Azure services to the far edge with Microsoft Azure Stack Edge. My name is Janaka Rangama, and I'm joined with my esteemed colleague Chris Turner to present this session today. A little bit about myself. I'm a senior principal engineering technologist for the Azure Stack family of products at Dell Technologies. I've been a Microsoft MVP and an MCD for a couple of years now. I've written a few books and I lead a few communities here in Australia and in my motherland, Sri Lanka as well. If you want to connect with me, my details are on LinkedIn and Twitter on the screen. Now, I'm going to hand over to my amazing colleague, Chris Turner, who's actually going to demonstrate today's live demo from his home state while attending to his friends at the farm. Chris, over to you.
Thank you, Janica. Hi, my name is Chris Turner, also known as the Country Cloud Boy. I'm an Azure customer engineer working at Microsoft. Today I'm pretty excited. Why? Because I'm going to show you how to bring Azure services like machine learning, stream analytics. Let me get that phone call. Azure Custom Visions, all to your Azure Stack Edge by using custom IoT modules.
Thank you, Chris. Now, before we start talking about the Azure Stack Edge, it's pivotal to have a little bit of understanding of the intelligent edge ecosystem in Microsoft product portfolio. On your left-hand side, what you see is the tiniest point of entry to this ecosystem, whereas on your right-hand side, it denotes the hyperscale cloud that Microsoft is running. So starting with things like Azure Sphere, which is a dedicated MCU that runs the Azure Sphere Linux OS for modern MCUs, and all the way up to the fully fledged Microsoft Azure cloud system. Microsoft provides a plethora of devices, capabilities, and services for you to bring out your applications to the far edge. Now, for sensors and controls, as I mentioned earlier, you have Azure Sphere and you have the Azure IoT device SDK enabled IoT devices that you can leverage, and you can generate the data and the telemetry you want to ingest into Azure. Then, if you want to work with things like interactive sensors, for an example, like drones and stuff like that, in that case, those things are considered as edge devices. Now, these edge devices have to leverage Edge Runtime, which is provided by the Azure IoT Edge. So it allows you to deploy and manage Azure services as containers on any IoT device, literally. So some of those services are the AI, Azure ML, Azure Stream Analytics, and there's more of these. Now, in order to process the data gathered from those sensors and controls and interactive sensors on edge devices, you need some sort of a compute or a platform to process this data. Here's where the Azure Data Box Edge, Azure Stack Edge, and Azure Stack Hub is coming into the picture. Now, Azure Stack Edge, previously known as the Databox Edge, is an AI-enabled storage and compute Azure Edge appliance. So one new server provides you just enough compute to run those Edge Azure services. Whereas the Azure Stack Hub, previously known as Azure Stack, is a cloud consistent edge. So basically it provides a large subset of services that is available in Microsoft Azure and is considered as an extension of Microsoft Azure. So scenarios like edge are disconnected, regulatory requirements, and making the cloud app model on premises would be ideal use cases for this product. And finally, you have the full range hyperscale cloud services with Microsoft Azure. Now, these services can be offered as tiered services, and there's a plethora of open source based services and tools with Microsoft Azure. Now let's move on to today's topic, the Azure Stack Edge, or previously known as Databox Edge. As I mentioned earlier, it's a single one new server, and it is an Azure managed edge appliance that brings the compute, storage, and intelligence of Azure right to where you need it. What do you mean by that? Now I mentioned this is a one new server, and inside that there's just enough compute for you to run those edge workloads. So some of those edge workloads are listed down here. So you can do things like hardware accelerated machine learning, you can use edge compute, and you can use as a cloud storage gateway where you can storage your data to Azure over network while retaining local access to the files you need. And of course, it's managed by Azure portal itself. Now, when we talk about management using the Azure Stack Edge, so couple of things to keep in mind. Now, when you want to order one of these devices, it's just easy as logging into your Azure portal and ordering one. It adds to your Azure bill, and it's you don't have any minimum period or hardware to purchase because Microsoft abstract that to your monthly Azure cost. Your configuration, access, and what workloads you want to run in these devices all are managed from the cloud. So you push that from Microsoft Azure. You can use the standard Azure management tools that you're used to now because it's considered as a resource in Azure which plugs into the standard Azure management tools and APIs. What are the use cases for this product? Now, as I mentioned, we are talking about taking Azure's edge capabilities to the far edge. So from a case study perspective and use case perspective, there are three main cases that you can use Azure Stack Edge. Machine learning at the edge, edge computer and IoT solutions, and network data transfer from edge to the cloud. I'm going to discuss about some of these and showcase a demo on how to use Azure IoT Edge and the other IoT capabilities at the end of the session. So when you want to run hardware accelerated machine learning with the Azure Stack Edge, it provides you a choice from NVIDIA T4 GPU or Intel Aria 10 FPGA. And you can use Azure Machine Learning Services or any other open source AI models. And it allows you to run inferencing and train your machine learning models at the edge with GPU processing. When it comes to edge compute, you want to run Azure services at the edge locations where there might be a proper data center location or not. So either these workloads will be either VMs or containers. And when you want to scale these compute workloads, you'll be scaling this across a Kubernetes cluster for performance and high availability. It's a cloud managed appliance, which you order from the Azure portal, like I said. And all the VMs, containers, and the workloads you deploy in Azure Stack Edge are managed in the Azure portal itself. And you use the same hybrid cloud management ecosystem with Azure Stack Edge to manage it. It can be used as a cloud storage gateway where you transfer your data from on-premises to Azure for backup, archival, or cloud scale processing. You can also optimize the data transfer using throttling and local caching. And when you have a network disruption, you don't have to worry because the appliance is aware about any disruption happening and it'll process once it restores the connection back to the cloud. When we look at the solution architecture of this product, as you can see, all your on-premises telemetry generating devices are connecting to Azure Stack Edge, which then filters out what data is needed and what is not and sends it to the relevant services in Azure Cloud. So you can run local edge compute, you can run local storage and hardware accelerated machine learning services, filter out the data you need and send it to the public cloud for further processing. Let's take a look at how Azure Stack Edge does the hardware accelerated machine learning. Now with hardware accelerated machine learning on Azure Stack Edge, it processes the data locally. Now where it is generated, the reason is to generate immediate results. Now these results can be used to act upon in the cloud or on local systems. So basically you can transfer or keep the processed data. So a good example would be if you deploy a trained machine learning model on an algorithm on an Azure Stack Edge. Now it can process the known data and send the anomalies back to Azure. So if it's an inferencing application, all the local inferencing results or the known results are processed immediately. It provides you two GPU options, with one with FPGA with Azure Machine Learning, and it's automatically accelerated on the FPGA. And for dedicated GPU, it provides NVIDIA T4 GPU, which is currently on a preview, and it supports Azure ML, Onyx, and NVIDIA EdgeX for things like DeepStream, TensorFlow, and much more. What about compute on Azure Stack Edge? Now, as I mentioned, this device is not a full-fledged computer. It's not your just VM dispenser. Rather, we are deploying intelligent compute on this edge appliance. So we can deploy things like Azure IoT Edge and use that to deploy and manage containers from Azure IoT Hub and integrate your solution at the edge. You can deploy Kubernetes clusters to scale across multiple nodes to provide a cluster of appliances, so you can manage your workloads from cloud or edge. If you want to bring your virtual machines, just virtual machines, to the edge, which are not containerized, basically Windows or Linux VMs, you can do that in Azure Stack Edge as well. But bear in mind, this has a limited capacity, so there's a limitation to what sort of VMs you can deploy. So the Kubernetes and virtual machines at the edge are previews. Private previews as of now, and public previews of this product is coming soon. Now, when we talk about the Azure IoT Edge, it provides Azure IoT Edge modules so that you can run Azure services literally on any device. Some of these services will be AI, Azure ML, Stream Analytics, Azure Functions, SQL, and bring your own code as well. It provides support for open source and Linux and an expanding set of OSs. As always, Azure IoT Edge is cloud managed. What you mean by that is it's managed by Microsoft Azure itself. If we look at the Azure IoT Edge deployment into the Azure Stack Edge, what's behind the screens? This is a sample example of the deployment, and during the demo, Chris will explain in depth how we deploy and manage Azure IoT Edge into Azure Stack Edge. Now, basically, what happens here is in the Azure Stack Edge, you will deploy the Azure IoT Edge as a containerized instance. Now, you'll pull the relevant containers from Azure Container Registry that is running up on Azure. The deployment manifests and the other containers, and you can pull things like Azure IoT Hub, some other Azure services like Stream Analytics, Machine Learning, and if you want any other third-party service like data conversion, and if you have custom code, that also you can deploy. So you pull the containers that contains the Azure IoT Edge deployment from the Azure Container Registry, and you send back the device configuration and management information back to Azure. Now, what about Kubernetes on Azure Stack Edge? Now, on Azure Stack Edge, under an hour, you can start from plugging your Azure Stack Edge applications to running applications on Kubernetes cluster on an Azure Stack Edge instance. So which is pretty impressive and fast. Now what does it provide? So with Kubernetes, it provides a couple of important characteristics when you're running that on Azure Stack Edge. So you can scale workloads at the edge for requirements like if you want to scale compute, you can leverage the FPGA or CPU, GPU acceleration across the Kubernetes cluster, and you can use the persistent storage that is available on the Azure Stack Edge to scale storage on the Kubernetes cluster you created. And you can build multiple clusters across multiple appliances to improve resiliency. Now, managing this Kubernetes workload that is running on Azure, as I mentioned, is through Azure Portal. We leverage a few things for that, like depending on where you use this Kubernetes cluster and its usage. For example, if it's a Kubernetes cluster that where you use Azure IoT Edge as well, so you can use Azure IoT Edge tools and native Kubernetes tools over local network to manage it locally. And if you want to expose it over to Azure as an Azure resource, the Kubernetes cluster itself, you can use Azure Arc for Kubernetes. Now, when we take a look at the Kubernetes deployment on Azure Stack Edge, which is on a preview, as you can see, inside the appliance, there are master nodes and worker nodes running as a standard Kubernetes cluster. And inside the master node, there's an Azure Arc agent if you want to expose the Kubernetes cluster as an Azure resource in Azure. So inside the worker nodes, it's talking to the relevant Azure services to get that information from. Also, you can use your regular services that you use to manage the Kubernetes cluster. For an example, kubecontrol to the local management of the Kubernetes cluster. You can use that for local management as well. Now, many of the Azure services are offered as containerized edge versions. Things like Azure Cognitive Services, Azure Machine Learning, Stream Analytics, Azure Functions, SQL Database at the Edge, and Azure Event Grid. Or if you want to improve your own service into Azure Stack Edge and run it on a container at the edge, you can write your own or third-party software that is supported to be executed within a Linux container. Now, the final capability we are discussing today is the virtual machines. Now, this is a great option for compute tasks that are not containerized yet, but small in scale. Remember, this is a one new appliance, so it has a limited capacity. So this is designed for basic configurations and can run both Linux and Windows virtual machine. There are some additional features that will be available with virtual machines on Azure Stack Edge to provide high availability and disaster recovery capabilities. Now, for an example, there's capabilities where you can cluster Azure Stack Edge devices. Now, what will this do is it provides clustering the Azure Stack Edge devices so that you can stay reliable or scale up the workloads that requires more than one compute appliance. So basically, if you need more and more virtual machines in a single edge location, you can cluster them. So this is actually a new feature which is coming soon. And these clusters are created and managed from Azure Portal, as you might have already guessed. I mentioned that you can use the Azure Stack Edge as a storage gateway that extends the Azure storage to the edge. What you can do here is you can expose the SMB and NFS shares on your local network, and it literally acts as a gateway to an Azure storage account. You will keep a local cache of your recent files for local access, and all you need to do is copy to a local file share, and Microsoft does the uploads for you. Alright, we've talked a lot about the Azure Stack Edge appliance. It's time for some cool demo. So my colleague Christopher Turner, who's doing the demo from his homestead while attending to his friends at his farm, is going to show you how to work with Azure IoT Edge on Azure Stack Edge. Chris, the stage is on for you.
I'm excited. I'm pretty sure she's excited. And, well, I don't know about him, but she is definitely excited. So, hey, let's get this demo started. I'll see you inside. Today I'm planning on showing you the power of Azure Stack Edge and what we can currently do with the product. If we have some time, I'll be able to show you some of the future services coming soon that will make this product even better. I'll be building and deploying several custom modules to my Azure Stack Edge I have running at my house. Today, everything I'll be doing is going to be between Azure and Azure Stack Edge. However, some of these new features coming soon to Azure Stack Hub will allow me to truly run everything on the edge. If time allows, I'll be deploying Azure Stream Analytics as an IoT Edge module, which will allow us to take the Azure Stream Analytics logic and move it to the device itself. By processing telemetry streams at the edge, we could reduce the amount of uploaded data and reduce the time it takes to reach insights. The next module I plan to demo enables us to move workloads out of the cloud and onto the edge. This lends itself well to services that process tons of data, like our computer vision module. We'll build a custom image classifier and deploy them to our IoT edge devices as containers. This can enable us to find insights from images and video streams without even having to transfer the data all the way to the cloud itself. Now, time permitting, I would really want to dig in and get even deeper with the Azure Machine Learning as an IoT Edge module. The demo will use simulated machine temperature data that will then predict which device may fail sooner than later. I would also love to show you how to deploy Azure functions on the edge that could also enable us to filter sensor data on a simulated IoT Edge device. So let's jump into our demos. Okay, so my first demo, I'm going to actually deploy Azure Stream Analytics as an IoT Edge module. So the first thing that we're going to actually do is we actually need to create an Azure Stream Analytics job. With that, we actually create a storage account. I've already got that done. Then we're actually going to go to and create, of course, a new Stream Analytics job. How do we do that? Well, we do it in Azure Portal. This one is all going to be pretty much portal-based. The next example, the demo I'm going to show, will be more VS Code and how to deploy a module via VS Code. So this one's all going to be pretty much click, and copy and paste. So here we go. We've got, we're going to go ahead and create a resource. We're going to go down and create one from IoT things, Internet of Things, IoT, love that, yep, And we're going to go over to Stream Analytics job. I'm going to wait a few hours here, just kidding. We're going to go to create this name, pretty much simple. That way it doesn't confuse me later down in life. Just going to go to my subscription. Just going to go into a resource group I've already created. I'm going to throw it over in West US 2 because I'm closer to West US 2. It's going to be, hosting environment is going to be Edge, and we're going to hit create. And then we're going to wait a few seconds, minutes, however you want to call it. Now we need to configure this job. So I'm going to go over to our IoT Hub. Actually, sorry about that. I'm going to actually go to our job that we just created. Here we got it. We got our IoT Edge. We're going to first, we're going to add some inputs. Add an input stream. We're going to call this one, of course, it's going to be an Edge Hub. We're going to call this one temperature, lowercase. Everything else is going to be default. We're going to make sure I don't fat fingers these things. This live demo, anything could happen. By the way, I could hit pause and correct it and make myself look really smart. We're actually going to go back down to outputs, and we're going to add an output. Same thing, Edge Hub. We can actually output data to SQL databases too, but this time around we're going to actually output it to Edge. This one we are going to name our alias alerts, or alerts. I guess you could single quote, I don't know. We're going to hit save, and then we're going to go to create a query. This query is predefined in the document that I'm using, that you guys could actually use as well to play with these demos. And then I'm going to save query. Now we're going to configure our storage account. Under configure, storage account settings, add storage account. I already have a storage account created. I've got the key in there. And I've created some demos in the past, but I'm going to create another demo, that way we have view data. Stream. Hit save. And hit yes. Container successfully created. Now we're actually ready to actually deploy the Azure Stream Analytics Lab to our IoT Edge device. In this demo, we're actually going to use the set modules wizard in the portal. It's going to create a deploy manifest. It's a JSON file, and it basically describes all the modules that we're going to deploy to this device, the container registries, the store, where we store those model images, how the modules should be managed, etc., etc. For this demo, we're actually going to deploy two modules as well. The first one is a predefined, pre-made module. It's a simulated temperature sensor that we're going to quickly deploy. And then we're going to create and deploy our Stream Analytics module as well. So we're going to go to our IoT Hub, which I have right here. We're going to go down to IoT Edge. And then we're going to go and hit, make sure when it loads, we're going to see that here's my IoT Edge device. It's actually my Azure Stack Edge running at my house. You could simulate these by creating your own Linux or Windows machines and having a virtualized Edge solution if you don't have an Azure Stack Edge to kind of play with these demos as well. But we're going to click on this. Currently, I only have one single custom module running, and that's basically a log module that a internal Microsoft employee created that sucks the logs from containers and modules that are running and throws them to log analytics. That way we have an easier way of troubleshooting. So we're going to go up to set module, and we're going to hit add. And we're going to hit IoT Edge module. This one's going to be our simulated temperature sensor. So we're just going to paste that here, and we're going to enter a path to the actual container, image container that's already created for us. Make sure everything's in there correct. We're going to hit add. Then we're going to go and add our Stream Analytics module. We're going to hit add again. This time we're going to click Azure Stream Analytics module. We're going to go to my subscription. You're going to see that it already exists, the only one that I have currently, and we're going to hit save. Give it a few seconds. I could tell some cheesy jokes if you want. Play the Jeopardy music. Shouldn't take too long here. It's been added. Yay, congratulations. The next step is to actually add some routes. That way we could the modules know where the route data and such. So the routes that we're going to be defining here basically define the flow of the data through the IoT Edge device. It basically takes telemetry data from the simulated temperature sensor, and then it sends it over to the IoT Hub and over to the temperature input. That was configured in the Stream Analytics job that we configured earlier. And then the alert output messages are then sent to IoT Hub, and to the simulated temperature sensor module to trigger the reset command, things like that. So I'm going to click on routes here, and lo and behold, they already exist because I'm that great. Actually, I forgot to delete those routes from when I was testing these demos earlier. But now you don't have to watch me copy and paste. How about that magic, right? I'm that good. I mean, I'm so good that it knew to self-populate. Yeah. Anyway, so we're going to review and create. We're going to see the actual JSON file, the deployment file that's going to be created based off of what we just did. In my next demo, hopefully, if I have time to do my next demo, I'm going to actually show you how to actually build these out in VS Code and how to actually deploy from VS Code itself using these JSON deployment files. So we're going to hit create, and stop blabbing here. Modules have been set. Now we could see that we have our IoT Edge job module. That's the Stream Analytics module that we just deployed. We also have our simulated temperature sensor module. Everything's running great. There's no exit codes, which is good, because if we had exit codes, then we'd have something bad. The next thing to do is actually show you that this is working. So we're going to run over to, we're going to click over here to Log Analytics. I've got a predefined query that when I hit run, I'm hoping it's going to work. Look at that. Great. So as you can see, we're going to start getting data in, and we're going to get, it's falsified data, of course, because it's simulated data. I don't want to say falsified because, anyway, it's coming in from our simulated temperature sensor. And this is the data that it's sending. And you can see as we get closer, the temperature is rising and rising and rising. When it gets to certain temperatures, that's when some of the alerts that we can configure to alert people, things like that. So I can sit here a few times and keep hitting run, and you can see that the simulated IoT device is actually sending data, and as it should. But at this point, for this demo, this is done, and I'm going to move on to the next demo, hopefully. But I do want to point out what's going to happen here is this is going to continue to rise, right? Once that machine's temperature gets to 70 degrees for over 30 seconds, that's when our Stream Analytics module trigger is going to reset, and the machine temperature is going to drop back down to 21. So in theory, if we keep sitting here, we're going to see some more logs. But I'm going to let this run, and we're going to go on to our next module, which our next module I'm going to try and, well, actually not going to try, I'm going to actually demo how to bring Azure, the Azure service, some cognitive services going like custom vision down to Azure Stack Edge as well. So for now, we're just going to leave this and let it run, and hopefully come back and I'll show some of the more logs that where we can actually see the Stream Analytics trigger and do its job. Okay, so my next demo is going to be how to perform image classifications at the edge with our custom vision service. So the first thing we're going to do is I want to talk a little bit about the modules and how things are going to work. I previously did this in another demo where we try to identify sheep versus donkeys versus cows. But today we're going to use kind of a different method here. The first thing we're going to do, of course, is we got our develop machine. We got Docker installed, Visual Studio Code installed, a whole bunch of other prerequisites. We're going to be using Custom Vision Service in Azure to train our module, and we're going to then build a module called our classifier, export it, and then Visual Studio build that module, and then push it to Azure Container Registry Service, and then we're going to deploy it to our IoT Edge device, which is our Azure Stack Edge device at this point. And then we're also going to deploy another module called the Camera Capture module. This one is basically going to, it's a simulator that's going to simulate images being pushed to our classifier. in the rural scenario, you would probably use like a live RTSP feed or some kind of feed that's constantly loading images and things in that source, and then the classifier will ingest those images and classifying debate based off of how that classifier was trained. So first thing we're going to do is we want to actually go in and we're going to build an image classifier using custom visions. We're going to log into our custom visions portal, and we're going to create an actual custom vision project. It's already been pre-created because it takes some time. What I did is I uploaded some stock photos that were provided in a demo from Microsoft Docs, and some of them are hemlock and some of them are Japanese cherries. Each of these folders have been tagged based off of what kind of a leaf or tree they're from, or bush, to be honest. And then we train it. When we're done training, then we could actually export this into a Docker image that we could then drop down into our dev box, and then we can actually build that module that we're going to deploy to our IoT Edge device, which is our Azure Stack Edge. So like once we train, it kind of goes through all the images, and it could pretty much guarantee that not guarantee, but it has a pretty high percentage rate that it knows exactly what a Japanese cherry is going to look like and what hemlock is going to look like. This is where we export. We can export to a Docker file, and then we can go in and go into Visual Studio Code and start creating these modules. Because we're kind of running a little short on time for this demo, I'm just going to walk us through how this was done. I'm going to show you how we did it within Visual Studio. I'm going to run through the process of building the module and pushing the module, and then I'm going to go over and show you what happens in IoT Hub, and then what actually happens on the Edge device as well. So we're going to come over to Visual Studio Code. Inside Visual Studio Code, you see our project here that we've pre-created. It currently exists. It only currently exists with two modules. We have a camera capture module, which is the module that I was talking about, which is basically a simulator, and we've got our classifier module. The camera capture model, we have a test image that we've kind of pre-fed into it, and what this camera capture model is going to do is it's going to constantly just push this image randomly or to our classifier. And the classifier is going to take hold of this, and using some of its intelligence that we've trained into that classifier previously, it's hopefully going to be able to identify this as being, excuse if I can't remember the hemlock bush or tree or whatever you want to call it, plant. So at the end of the day, we're hoping that our AI and our cognitive service and everything works the way it should be. I didn't do a lot of training provided a lot of photos. So we'll see what happens, right? So one more time, the classifier is the module that's going to classify these images, and then tell us what it is. This is a solution that we could use for identifying traffic patterns, identifying if garages are full or not, things like that. There's a whole bunch of real-world cases behind this, especially if you're ingesting live feeds from live cameras and stuff. So once we have this built, these are Python modules. You could have C#, you could have Java-based modules, but these two modules are basically Python modules. Excuse me. We have an environment finder that kind of basically tells us the password and the username for our container registry. And then we have some deployment templates. The deployment template for this one is pre-created. We did have to do some editing. I'm going over this really fast. One of the when I deploy this deployment template, anything that's on my Edge device right now is going to be wiped, and so I'm going to lose all my modules that I currently have on there. So I wanted to make sure that I'm keeping that logging module on, so I could dump logs over to Log Analytics. So I kind of edited this deployment template myself and added the path to the gentleman's container image. And of course, we added the routes in here, so we don't have to manually add them in the portal. Once we deploy this, we're actually going to come over and we're going to actually deploy, build and push an IoT Edge solution. So what's going to happen is it's going to build these two modules locally using creating Docker images. Then it's going to push those Docker images over to ACR. When that's done, we can then go back. It's going to create a config file for deployment. Then we can deploy the solution to whatever edge solution we have, be it an Azure Stack Edge device or Edge running on Azure Stack Hub or just Linux test system itself. Really wish I had a little more time for this one. This one is pretty nice because it goes into more detail, but just at high level, just to get your feet wet and to understand how modules are built using VS Code and how they're deployed. Maybe some other time we could do a whole hour-long session on and go more into detail here. Also using Azure DevOps and CI/CD pipelines and how to create and push and maintain your modules as well. That would be something very nice as well. So we don't got too much time. So what I'm going to do is I've already actually deployed a lot of this stuff to kind of save us some time. What I'm going to do is kind of do an example. I'm going to go here, build and push an IoT Edge solution. In theory, it's going to push, it's going to build the images using Docker, and then it's going to push them to ACR. But since these are already built and already pushed, wow, magically they're there. So now we want to deploy our solution. And we're going to deploy it using our deployment manifest file. It's pretty simple. There's various ways you could do it. You go down to the edge device that you want to push it to, or you could actually just go up to the config file that's been created, right click, create a deployment for a single device, or create a deployment at scale. So let's say you have 1,000 edge devices spread across different oil fields or different corporate farms or whatever you want to call it, and you wanted to send out a module that was going to go out to each of them. This is when you would deploy at scale. For me, we're going to do a single device. It already has been populated knowing which IoT edge device I'm going to be using. We click on it, it starts the deployment. Deployment is successful. We come over here to our IoT hub here. And then we're going to go down to IoT Edge. We're going to refresh. This is my, I'm going to refresh this. This is going to be my Azure Stack Edge. You'll see that it's running okay, which is always good, especially after pushing deployments. That's very good. You see that now we have my 3 modules that are running. We have our log spout. I have my classifier and our capture image. Those are running. There's no errors reporting, which is always it's always a good thing. Usually this takes a few minutes and it's going to overwrite itself. So hopefully when we go to look at these logs to find out what is going on, that and to see if the classifier actually works, that everything's happy and hunky-dory, right? So let's go to our log analytics workspace. We're gonna look up the log real fast because I don't remember the query offhand to find this out for me real fast. Okay, this is just gonna give us a whole bunch of data. I'll worry about it in a second. We should be seeing some information from our here shortly. Got some old data here. So live demo, well, sort of live demo. I've been sitting here waiting for data to come and come and come. So I'm going to troubleshoot here, which I kind of already know what the problem is. Basically, there's some settings that I didn't change in my deployment JSON for the specific module that's pumping the logs into log analytics. And how I could actually kind of tell that. We're going to go back to IoT Hub. I'm going to go down to IoT devices, actually, no, IoT Edge. We're going to click open our Edge device. And we're going to click over our log spout. And we're going to figure out that, yes, this is the problem. So I've got an old workspace ID and a old secret from an old configuration that I copied over. So I'm going to go and fix that real fast. And to do that, we're going to look into our file here. So as you can see, this is my deployment template JSON. Here is our modules that we're going to be deploying. That this deployment would deploy. Under create options, I copied and pasted I cheated from an old deployment that I used in a different demo, and it's pointing to a different log analytics workspace, and that's why it's not working. So we're going to go ahead and fix that really fast. So I'm going to magically change this. Well, not magically. I'm going to do it live. Well, as live as I can get. Right. And hopefully nothing will break. Nothing more than it's already broken. And for you guys that are trying to be sneaky, this workspace will be deleted before long, so it won't matter if I show you that information. We're going to save our file. Now that we have the correct information, we're going to deploy this manifest, delete this manifest file here, just because I want to. Then we're going to right click. If I do a build and push, it'll kind of do the same thing, or I could just generate an IT edge deployment manifest, which is what I'm going to do here. So it's not going to actually build anything and push it at this point because we don't need that. I'll come up here. I'm going to create a deployment for a single device again. Choose my device. It's going to deploy to my edge device, and then deployment is successful. Now if you go back to our portal, and it's going to repush everything, so it's going to take some time before other stuff is ready and before that data starts coming in. I can sit here and tell some jokes. What do you call a dairy cow that isn't producing milk? A milk dud. Thank you. Anyway, quick little tidbit here. So I've logged in via PowerShell to my Azure Stack Edge, and then I'm able to actually see some of the images running on there. And as you can see, the log spout is the most recently deployed, which means it should have its new settings, and we should be able to see that it's what we desire versus what it has. Should match up with our current log analytics, which looks pretty much correct at this point. So at this point, we're going to go back over to our log analytics workspace and our logs. We're going to just run a simple search, and hopefully I didn't waste our time. And then we actually have some logs that are coming in. Sweet. There we go. We got some updated logs coming in. Now what I want to do is I want to get logs and see what's coming in from camera capture and also what's coming from the classifier as well. So I'm going to run the logs one more time here. And now we'll start seeing some logs coming in both from the camera capture and the classifier. As you can see, the camera capture sent a total of 16 images, which is the same image we've had, over to the classifier, because that's all it's a dumb little simulation. It's going to always send that over. The classifier is going to grab that image, crop it, try to read it, use some intelligence to try to see what that is, and then it's going to compare it to what we trained it. So we're actually going to look for something like this result here from the classifier. This is going to tell us what the classifier, what the intelligence thinks it is. So as we can see, the prediction that it thinks, actually the prediction is that it has a high probability of it being hemlock, which I'm pretty sure that was a hemlock leaf or bush. So at this point, we have enough intelligence that this module, this classifier, knows that this is a hemlock image, and based on what we need to do with this image is, if it's not a hemlock image, it could be uploaded to some other storage, Azure storage devices, either on Stack or on Azure Stack Hub, or either in Azure itself, and then other services could take advantage of the data now as well. So in the long run, we ran out of time, so I can't show you more demos. I wish I could show you some more, but we did the 2 demos. We did the first demo with the Stream Analytics, and we also did the demo of this one here with Custom Vision, both being located on our IoT Edge device, which is actually our Azure Stack Edge device, and having pretty much the Azure services running on our Edge device to be able to help us manage the data, manage our images, manage anything that you can think of before we send that data up to the cloud or over to Azure Stack Hub for other tools to take advantage of. So in a nutshell, that was my first 2 demos. I just want to thank Jenica, and I want to thank Dave and Crystal from MVPDays for letting us have this opportunity to show you a little bit about Azure Stack Edge and things that you could do on Azure Stack Edge and Azure Stack Hub. I truly hope those were not very bad demos. Do you get it? Sheep, bad. Anyway, sorry. Thanks again. Hope you had a good time. Hope those demos are worth it. Thank you. Bye.
Thanks for that amazing demo, Chris. We always value your feedback, and we highly appreciate that you joined this session today. And we hope to see you in another episode of MVPDays conference. Stay tuned, and thank you, and have a lovely day.